Hello and welcome to the DevOps Fundamentals series. In this series I'll be joined by a few Microsoft experts, and we're going to help you make sense of the DevOps culture, and also later on in the other episodes we're also going to cover some of its main practices, the ones that we've identified that are more common. This episode we're going to cover an introduction to DevOps, and then further on we're going to drill into specific DevOps practices. So just to introduce myself, I am Thiago Almeida. You can find me on Twitter at NZThiago. I'm a senior technical evangelist here at Microsoft, and I've been talking to customers, working with and presenting about DevOps for the past year here. And you can also find me on my blog at talmeida.net. And for this episode, I'm joined by David Tesar. David, do you want to introduce yourself?
Yeah, sure. Yeah, great. David Tesar, Senior Technical Evangelist at Microsoft, also focused on DevOps. I, though, have the Ops background. You could watch episode 0 of DevOps Dimension Show if you want to get more history on Thiago and I here. But nonetheless, I lead our DevOps Technical Working Group, and here to help you today learn a little bit about Microsoft's view on DevOps.
Cool. All right, we'll get started then. So like David mentioned, this is our view of DevOps. That's the DevOps story from Microsoft here. And to step back a little bit, we want to talk to you about how it used to be the traditional development and operations teams, how they used to work, or a lot of them still do it nowadays. Originally, the development team would just create a package or create a solution that they wanted to get to production and toss it over the wall of confusion to the operations team. The operations team would then start preparing to put that into production and manually change configuration files, create or change the environment in production to make sure that it was appropriate for what they wanted to deploy. And of course, eventually there was a lot of duplication from what development and QA had to do to what the production operations team was doing. And of course, a lot of times they run into problems, bugs that they couldn't find in development, and then the development team gets called in. You have just that window of time where you can get that solution into production, and development gets called in, and they say, hey, it was working fine on our environment, and now it isn't working in production, so it must be an ops problem. And ops said, well, you gave us something that doesn't work in production, so it's a development problem.
Yeah, so I mean, this is just one major indicator of people when you know you're not doing DevOps, right? Like, if this is happening, you're not doing DevOps, right? I mean, there's other telltale signs that know that you're not doing DevOps, but this is one that I see a lot that happens, right? Yeah, I mean, ops should really be involved the whole time, and then avoiding these things.
Yeah. And so what should have been a deployment to production with no problems turns into this major problem with everyone involved getting called in the middle of the night to fix it. Yeah. And sometimes you don't have a specific way to roll back, so you end up with something sort of working in production as well.
If you have a war room for when you do a deployment or a release, yeah, that's not DevOps.
All right, so
let's keep
with
going.
that, what is DevOps? A lot of people have tried to explain or define what DevOps means. It's very challenging to do that. It's not like there's a manifesto like we had with Agile.
Yeah.
So some people say it's a collaboration between development and operations, but from experience we know that there's a lot more teams that get involved, not only dev and ops, but QA, security, the business, they all have to buy into that culture of DevOps. Some people say it's automation, you have to try to automate your whole environment as much as possible. So we'll prefer to just tell you what we think DevOps is about.
Yeah. There's one acronym that I like, but that's a little more deeper. It's CALMS, or culture, automation, lean, and metrics, and sharing. Right, it's the other one. But if you think about DevOps at a really high level, right? It's we look at it as it's people. It's about the people. It's dev, ops, business. Everybody really that's involved that needs to deliver value to the business is working very tightly together with that common goal of adding value to your customer. And then next, it's about process, right? Because even if you have those people that are just super good friends and they're working together, but then you've got business processes in place that are really blocking innovation. For instance, long change advisory boards before they can do something, or they're restricted to doing things a certain way that really inhibits that kind of innovation. That's probably, that's part of the bigger picture with DevOps, right? Enabling efficient flow of people working together and not having processes get in the way, but having processes and practices help enable that value delivered to your customers. And then last but not least, we do list products there. And I gotta say, just gotta explicitly call out, DevOps is not a tool or a product. You can't buy the DevOps, all right? There's no such thing as, give me the DevOps, here's my card, I'm gonna buy it, right? You can't do that, right? There's no DevOps in a box. It's magic here. But all that being said, naturally there are products, tools, services that really help enable different DevOps practices and that different teams could use to make things a little bit easier in that world. And we'll kind of break things down a little bit more for you in a second here.
Yeah, and like David mentioned, it's in this order. So if you have the people or the culture first nailed down, then you look into processes, and then eventually those will help you decide which products will help you implement the culture change or the processes.
Yeah, and it doesn't matter if it's Microsoft tools or not. I mean, if you start with tools, those tools are going to be only as impactful as the pocket of people who are using them, right? If it's only ops or only dev or only business people, they may be great, good and well, whether they're Microsoft tools or not, but they're really going to have only that limited scope or that limited impact, and you're not going to be doing DevOps just because you got a tool that's doing DevOps practice things, right?
Yeah.
Yeah. So let's keep going,
All right.
All right, so there's, this is becoming less and less of a concern these days, but we still have some folks who are not bought in, right? And it may not be you that's watching this video, but it may be your boss or your boss's boss or somebody else up in the management chain that says, DevOps, we don't need that. We don't have to care about DevOps. That's just a fad or a trend, right? It's cloud or agile. That's just a bunch of smoke, right? I mean, right? DevOps does have actual business impact, and there are a lot of reasons on why you might want to do it. This slide has a ton of different stats on it. Yeah. I'm not going to go through all of them, but we're just going to leave them here for you, and maybe some of those will resonate with you or other folks that may not be convinced on DevOps. One that I do like to call out is the one on the bottom right-hand corner, which is that how much more the cost is for a bug in production, right? You look there, 100 times more to find a bug in production than it is earlier in the life cycle. Now, DevOps, there's a lot of different things that can help with that metric, but that's one pain point, just one out of a many here. Getting back to kind of some of the reasons why you might consider want to move towards a DevOps model.
Cool.
And then this one I like a lot. It is a DevOps report that's been done for a number of years in a row here. It is sponsored by Puppet Labs, but it is nothing in the report is like, hey, go buy this, right? It's a survey of a lot of people in the industry, hundreds of folks all around the world some of which are implementing DevOps practices, some of which who are not. And there's a lot of good insights behind this. One of the ones that you'll find out in the top left is that high-performing organizations are twice as likely to exceed their profitability, market share, and productivity goals, right? So really there's a bottom dollar here. And so if you're talking to, if you are a decision maker or a boss and you're thinking about this, right? If your competition is making 2 times as much, or wouldn't you like to make 2 times as much money by doing these kinds of things, right? So that was the real data that we found. Also, how do you get to become a highly performing, IT performing organization? Well, they found that DevOps practices actually improve the IT performance, and we'll explain to you in a second what that means. The other big thing that I find that's really important to point out here is on the stats on the right-hand side. And you'll see that most organizations, right, they have goals, especially if you're in a siloed organization or you have metrics that are not shared across Dev and Ops. This is a common scenario that you'll have is developers, they'll be geared at deploying new features, new code, new software at a fast rate. Like, get the new features out there. Even if you're doing Agile, it's like align it to the business and be happy, right? conflicts with what most ops teams' goals are, which is have things very stable, have very little change, right? Don't disturb what's working, because every time you push stuff there, it's going to break stuff, and that causes outages, right? And so when you have these two goals, it seems like more change and less change, and they kind of butt heads, right?
It's the exact opposite.
Yeah, exact opposite, right? And so the stats on the right-hand side are, I like to say, is a proof point that you can have both, right? You can have your cake and you can eat it too, right? You can have more change and more stability at the same time by implementing DevOps. And the proof here is in the stats, right? High-performing organizations deploy code 30 times faster and 200 times shorter lead time, meaning new concept of idea to customers' hands, right? That's 200 times faster than their lower performing peers. And also, at the same time, have 60 times fewer failures and recover from those failures 168 times faster. So that's a pretty big difference, right? I mean, if you're an organization and perhaps you're the lower performing and you have somebody, even that's a startup or another competitor, who's operating at that kind of velocity, it's like, how long is it going to take for them to surpass you or start taking money away? So I like to say, DevOps is not something, it's like maybe we'll think about it. It's like, when are you going to go move to DevOps? Not a should we, I'm not sure. It's just a matter of time, really. Yeah.
Cool.
Yeah.
And then with all that being said, we still want to help you wrap your head around DevOps. Mainly because there's no specific definition of it, but also there's a lot of products that get associated with DevOps. And the culture, how do you correlate the culture and process and people and the business values that we've been discussing so far with an actual product like a chef recipe with a Linux VM deployed to Azure? So we have this idea of DevOps practices. And we can help you then map between the 100 level to the 300 level through a practice. Like, for example, here we have infrastructure as code, and treating your infrastructure as code, which will be the next episode of the series, and then the actual technologies that you might use to implement that kind of practice, right? And of course, remember, if you don't have the culture nailed down first, then don't try to keep going, change the culture inside the company first, but eventually you will get to implementing this, and because it's an IT organization or part of IT, you will have products and tools that you use to implement them.
Yeah, it's still useful. I mean, it's still useful to understand DevOps practices, right? And what they mean and kind of, what they are, even if you're not fully transformed yet, because, if and when your company does decide to move to get the DevOps team organizational structure and those things starting to come together, you're going to have skills that can be immediately useful, right? And there's nothing wrong with applying DevOps practices before you get there, right? It's still useful, it's still helpful, right? One of the undercurrents of DevOps is automation. DevOps practices are have an underpinning of automation as well as some of those tools. But the thing is like, if you just go straight to tools, once the team formation organization forms, the tool set that team uses may be something totally different. But if you understand these DevOps practices, those are going to transcend tools even over time, right? Just these are the way of doing things.
Yeah.
Yeah.
So with that, we have this list of DevOps practices. There are a list of practices that we've noticed are pretty common or recur quite a lot in companies that have implemented DevOps properly. And for example, we have infrastructure as code, treating your infrastructure as code, automated testing, running as many tests as possible in an automated fashion, release management, continuous integration and delivery. So there's quite a lot of those. On the left, we have the main ones. And then on the right, there's some of the most advanced ones. And we're going to have one episode for the next 8 type of the main ones. And then the last one, we're going to talk a little bit more about the more advanced practices as well. And with that, now that we understood what practices are and what the culture is, then we can start covering a little bit about the tools and products that you can use as well.
Okay. So we want to, really cover the tools at a very high level that Microsoft offers. And the first major, I'd say, tool bucket or suite, I guess if you want to call it, is Azure, right? Microsoft Azure has a ton of different services and a ton of things to offer there. But really having a cloud platform, whether it's Azure Stack, which is the on-premises version of Azure that you could run in your own data center potentially, or our public cloud Azure. Both of those provide a ton of different benefits and make things a lot easier for various implementing DevOps practices. Just giving a really simple example, for instance, infrastructure as code. Can you do infrastructure as code without Azure or Azure Stack? Absolutely, you totally can. But Azure makes it easy where that we just provide a platform for provisioning things with like a JSON file. Boom. There you go, right? It makes things a lot easier from provisioning and deprovisioning. And if you want to get a new server, it's not, oh, I need to go a whole process. It's boom, I have it up. It's up in seconds or minutes, and it's done, right? So Azure is our fundamental, one of our fundamental suites here.
It has a lot of automation that you can take advantage of as well.
Absolutely, yeah. Azure Automation. There's a ton of different products within Azure and services that really help enable different DevOps practices. Next up, I think it's also extremely important to point out that Microsoft Azure is very open. I know we keep beating this drum in a lot of ways, but it's really important that you understand that to use Microsoft Azure, you can really bring whatever you want, whether it's open source or not, right? You can pick and choose different aspects and enable that within your platform. So even if you want have a whole Linux stack, fine. We run Linux in Azure, right? You have MySQL, you have Java, PHP, Ruby, right? There's a whole list here of different options that we all are support and enable on Azure itself. So we really allow you a lot of choices in what you want you're working with for different DevOps practices and tool sets.
Cool.
The other major aspect, I'd say, suite of tools or product set that we have at Microsoft that really relates to DevOps practices is Visual Studio Team Services and Team Foundation Server. Visual Studio Team Services used to be called Visual Studio Online, but it is our cloud service, and the TFS would be our on-premises product. We've had TFS around for a really long time, and I think it's really important to point out that both of these suites have a strong foundation for automation and enabling agile as well as various DevOps practices. So, we have an entirely new build system, which is open, cross-plat, flexible. We'll show you just a ton of different partner integrations that we have here today. So both of these products enable way more than just source code and builds, right? And we don't really care which programming language you're using or which type of infrastructure, whether it's open source or not, you're using. This is a really big foundation for us that enables you to use things that you want. The other thing I'll point out is that we have this cadence at Microsoft and how we enable things. So the Visual Studio Team Services deploys to production roughly every 3 weeks. And every 3 weeks, those features get delivered to you in the public service, and then about once a quarter, those features get pushed back onto an update pack for Team Foundation Server, for those of you who want to run things on premises. And so it really enables you a lot of flexibility, and you could use certain services in the cloud, you could use certain services on premises. It really just is up to you. The other thing is you can pick and choose. Like, you don't have to go all in to everything, right? You might just use just build, right? Or just release for one or the other. And you can pick and choose which services you really want to use within this product set. All right. Yeah. And then just, again, hammering home the point of our openness and extensibility, right? I mean, this is a huge list of partners and folks that we've enabled on the platform, right? So, you see a lot of open source third-party partners here. We just had at the Connect conference, we talked about a partnership with Mac in the Cloud, where if you want to even do iOS, Android builds as a service and connect it up to our Visual Studio Team Services, that's an option, right? So really, I mean, there's all kinds of options for you, and no matter what walk of life you're in and what kind of apps or things you're developing, we really provide that platform and extensibility for you to choose the types of tools that you want and may be comfortable with, and have kind of best of breed options. I mean, of course you can go all in with everything if you want, but it's totally up to you, right? You could pick and choose tools that you're used to and use our service for other aspects.
Cool. Mm-hmm. Yeah, and then in the next few episodes, we're going to cover some areas of this as well, with doing everything with Visual Studio Team Services, or integrating with other external partners as well. All right, so let's cover the resources as well. Some resources that you can go out and research on your own about DevOps as well.
Okay. One of the things that we offer is Microsoft came up with something called the 7 Habits for DevOps Success. This is areas that we've identified from our own experience operating things like Visual Studio Online or Team Services, right, over a number of years, where we see are really important to moving towards DevOps. We have a self-assessment for you to be able to go and take online that will give your company or organization a rough idea of where you're at within these kind of 7 categories that we have, and gives you some suggestions that you might make to help try and improve where you're at to move towards DevOps.
Yeah, and it's pretty helpful for you to identify in each one of those areas where might be the first step that you take towards implementing something in the DevOps path.
Yeah, and I would say, there's a lot of other options right here for a lot of other options here for kind of assessment. The one of the aspects would be what's called a value stream map, and partners. I know that within the technical working group we've done these kind of exercises, but that's one option for assessment of where you're at. There's a lot of different ways to kind of address where are you at in terms of your adoption of DevOps, because as we've kind of mentioned a number of times here, tools is only going to get you so far, and although for the rest of this course, you're going to focus on enabling specific DevOps practices, that is something that you need to address. And there's partners that are out there that can help you with this. There's a number of different things you want to address to start to think about how are we going to tackle the kind of people aspects of bringing together all these folks to deliver value to your customers.
Yeah, we've run a couple of value stream maps, or quite a few of value stream maps exercises with customers of Microsoft, and it's really insightful what you identify by just having all the teams that are involved in the whole life cycle, and figuring out what areas they could improve or what areas they could automate as well. So they're definitely worth looking into.
Okay. Next up, another resource for you to check out is learning about how Microsoft does DevOps and the journey that we've made here. There's an Agile story, but there's also a recent DevOps one on how Microsoft has moved along to DevOps. And that is, that's the short URL, aka.ms/our DevOps journey. But that is, it really provides just some good ideas of how things are actually done. How do they have the roles? How are those different? We have a DevOps Dimension episode. Our first episode, in fact, we focused and we interviewed the service engineer, which is effectively ops, and a developer on how they interact and how the roles changed and shifted in this whole transformation. So that's something you can check out, learn more about on those links down below.
Cool. And we have a few more resources as well for you. First one is optimize your DevOps practices and tools. So that's the main landing page on the Microsoft for DevOps. We have our own show that we run as well, where we interview people from external companies, partners in Microsoft about their DevOps journey. So that's the DevOps Dimension show at aka.ms/DevOps Dimension. We have some technical resources as well on the
Microsoft Virtual Academy, MVA.
Yes, yeah. So there's a ton of content there as well on MVA. The self-assessment that David has covered already. And then finally, we have a whole lot of hands-on labs that you can then follow along at home. They use the Parts Unlimited and Parts Unlimited MRP samples that we've created so that you can then take those samples and implement some of the technology part of a practice at home or at your own pace.
Yeah.
So in that link is a blog post by David with the list of the both Microsoft and non-Microsoft workload that you can implement some of those practices.
Yeah, that may be something that we weave into other places down the road, but the main thing is that, and it's also important to point out, there's two applications. Parts Unlimited is the is the name of the thing that's referenced in the Phoenix project. It's just, it was, in the book. And so we wanted to kind of show you a practical way to implement some of the things they talked about in the book using Microsoft technologies. It's also important to point out that the Parts Unlimited app is two different apps, right? There's two of them. There's Parts Unlimited, which is a Azure website using SQL Azure, so it's kind of the pure PaaS Azure story.
Microsoft.
And, the Microsoft story with .NET, right? It's all Microsoft. And then we have the polar opposite of that, which is the Parts Unlimited MRP app, which stands for Manufacturing Resource Planning. It's also referenced in the book. But it is a Linux VM running MongoDB and the Java. So it's, with Apache Tomcat, right? It's nothing Microsoft at all, but we're showing you how to, connect that to Azure and Visual Studio Team Services and enable some of those DevOps practices that way.
Yeah.
So.
And on the next few episodes, we're going to use these two samples as well to show you a few of those implementations, so follow along if you want in the other ones.
Yeah, and then have those hands-on labs if you want to do those exercises yourself. Yeah, totally.
All right.
Okay.
We have a final slide.
So now, now we have, we're hoping that, through this series and other things, that you would be able to have happy DevOps. Really break down, right, this wall. Don't have any explosions, right? Break down the wall of confusion. Have DevOps get along. Start delivering, right? Start delivering those applications. And then start to really deliver those applications faster, right? Faster and faster until eventually you're going to have the awesome, right? The T-Rex Ninja Cat action that's it.
That's it.
That's it. So.
All right. So I hope you enjoyed this introduction to DevOps, and look out for the other DevOps fundamentals episodes that we'll have coming up in the next couple of months. Thank you. Technically, you don't really need to deploy the infrastructure until you are doing a release to an environment. Of course, it also fits into develop and test as well a little bit, so that you have to develop and create the infrastructure for your other environments as well. So if we're talking about infrastructure as code, what we mean is that it's a practice where you define the infrastructure of all the environments that are going to host one or more of your solutions or applications, and you use scripts and other files to do that. And you keep those scripts in the same source code repository or a different source code repository as the development team is using, so that you can have versioning of it, and you can also share the same environment description across multiple environments. Also, depending on the infrastructure that you're using to host your applications, you can do it imperatively with PowerShell scripts, Bash scripts, or other types of scripting, or also declaratively by configuration files that will be interpreted and then executed. Or, of course, you can do both.
Yeah, combine them.
Combine the two and then execute those across your multiple environments. There's a series of value adds that you get from this. You can see there optimized resources, accelerated delivery, a significant number of testing and deployment defects will happen when the environments are not aligned between each other. So defining the underlying infrastructure and then repeating that across the environments will reduce quite a lot of that. It also helps your development team, if you have them separate from ops team, to have a say in what the infrastructure will be in production and other environments, so that there's more of a communication between the teams, which is the whole idea of DevOps as well.
Actually, this is really one of the very important aspects of infrastructure as code. Forrester has a paper about this, infrastructure as code, the benefits, and they did a survey with like 300 people from enterprise companies. And one of the main things that came out of this survey is the developers and the operations team should be using the same tools, like same languages. I'm not talking about, the operations team should be learning to be a hardcore developer, but the two parties should be deciding on something that they would like invest time and efforts, like training budget, on that language or product.
Cool. So if you watch the first episode that we had, DevOps, an introduction to DevOps, we sort of introduced this idea of a DevOps frame where we map 300 level technologies back to the DevOps. So in this case here, we have at the 100 level the people, business practices that DevOps defines. So you can think of it like treating your infrastructure as commodity, having teams working with each other and similar practices like that. And then that sort of goes into infrastructure as code, which is the practice we're talking about today. Then finally, you can look at using ARM templates from Azure or Chef and Puppet with Microsoft Azure or other cloud providers. And that's the mapping that we have for this specific DevOps practice. All right, so we're going to get into it and show some demos.
The best part.
The best part. So to begin with, I'm going to cover the infrastructure as code with Azure Resource Manager templates. So Azure Resource Manager templates, they are templates that you use to define your infrastructure that will then be deployed to Azure. So to show you an example here, I have Visual Studio Code with a template here, DocumentDB website. And in here you can see we have parameters that are passed in via the parameters file so that you can change the parameters for the specific definition of your infrastructure. We have variables for in case you want to set values that will be used throughout your template. And finally, resources. In the resources section is where you define exactly what infrastructure you're going to deploy. So in this case here, I have a DocumentDB database account. I have a server farm or an app service plan is what they're called now. And then finally, a website. And you can go as far as defining things like for the website, I want to add an app setting called DocumentDB endpoint and reference the database account, the DocumentDB database account that was created earlier with the endpoint there. So once the website is up and the DocumentDB is already deployed, you can then link the two together and you have app settings for that. So to show you here, what you would do is you would do a Azure from the Azure CLI. You would do Azure group create, give the name of the Azure template group that you're creating, a location, West US in this case, the file that's going to define the infrastructure, which is the one I just showed you, DocumentDB website.json, and then finally a parameters file. To show you the parameters file, we have it here, and the only property here is the name of the project. And then I'm going to use that name across all of the infrastructure that I'm creating. So if I run this, that should kick off creating a new group on Azure. So that's run, and that basically told Azure, start creating this group for me. And I can also just do Azure group log show, and then the name of the group, Thiago DocDB node, and that should give you a list of all the logging that's being done for that group as it's being created. So you can see here it's actually just started deploying my solution. A little bit more advanced on Windows, let me just log in here.
And you can use PowerShell or even the portal to do exactly the same thing.
Yes, exactly. So here on a Windows machine, what I wanted to show you is from Visual Studio 2015, you can create a new project, and under Cloud, you have Azure Resource Group. For the Azure Resource Group, I'll just leave it with that name. You can see it has some existing templates here that you can take advantage of, like let's say a web app plus a SQL database. And that will go ahead and create that template file that I showed you from my Mac, and also create the parameters file that you need for this. So if we have a look at the solution here, you'll see templates, website, and SQL database. One cool thing from doing this in Visual Studio is that it also gives you a JSON outline here, listing all the parameters, variables, and the resources that you might be defining as part of your template. So you can see here it's defining a SQL server. Inside a SQL server, it's defining the database, a hosting plan, the website, and some settings for that website as well. And then finally, to show you a full-on definition in using ARM templates, we have the sample Parts Unlimited that you might have seen us mention before in this series. So for the Parts Unlimited, we actually have this template here called Demo Environment Setup with a whole lot of parameters, some variables, and then defining the resources, a SQL server, a database, a hosting plan, app insights, website, and website rules. Okay, so I'll show you one last thing, and that is from PowerShell how you would deploy this template, the demo environment setup. So to do that, I just called that PowerShell that Visual Studio created for me and pass in the parameters, Thiago PU for the storage account name, the resource group name, and then the template files, template and template file parameters. And that's just going to go ahead to Azure and deploy that template for us. What that looks like on Azure, let me just reload the Azure portal here. If I have a look at my resource groups that I have deployed, you see that I have that Parts Unlimited one deployed here. And it has basically the same things that we defined in our ARM template inside this new resource group that we've just deployed. So the Parts Unlimited server for SQL, the SQL database itself, a website, the hosting plan for it, a storage account, and the application insights definitions for it. So that's pretty cool, defining infrastructure as code using ARM templates. There's quite a lot of other resources here on Channel 9 and also online regarding to ARM templates, so look into that.
So let me talk about how things happen in the non-Microsoft world. This doesn't mean that we're not going to be using Microsoft platforms or just the opposite. We're going to be using Microsoft platforms, Microsoft Azure or Windows Server or SQL Server, but we'll be using non-Microsoft products like Chef and Puppet. The first example will be with Chef. Let me give you the concept about Chef. So they have a Chef server, and you have a workstation that you will be changing the cookbooks. Cookbooks and recipes mean that you are deciding on how to do things like I want Chef to connect to my virtual machine and install this feature. I want Chef to connect to my virtual machine or physical machine and install this package in Linux, for example. And you have nodes. The computers you are connecting are called nodes. So Chef server gives you the ability to do this centrally. So you can create policies, you can create roles, and you can decide, okay, these 5 machines are my web servers. So here's the configuration I want to be applied to these 5 virtual machines. These other 10 machines are my SQL servers, MySQL, SQL server, whatever. And I want to create a database on top of them when I'm creating them. This is just centralized and automated. And here is how it works with Azure. So you can see that you can keep your code in GitHub, in a repository in GitHub, even if it's related to infrastructure. One thing that is really changing the lives of ops is now we are more into coding. So we are now doing source control, versioning, that kind of stuff. This is really beneficial for the ops people because you know that from time to time you have problems and you spend a lot of time just trying to figure out what the problem was. It was working. It was working on the developer's workstation. It was working on a QA server. It was working on somewhere else. But the moment you deployed this to production, the moment you created some infrastructure in your production environment, it just stopped working. And you don't know why. Infrastructure as code gives you the ability to use a standardized approach. So if you are creating a virtual machine, every time you run this infrastructure as code part, it will give you exactly the same virtual machine, no changes. Same packages, same settings, even the same file under the same directory. So as in the slide shows here, you can use GitHub repository to put your infrastructure as code. And then from your admin workstation, you can just create some definitions like I want this, I want that. And then your workstation will connect to your Chef server or your Puppet server. And Chef server will then connect to your nodes, your endpoints, and apply this configuration to your nodes.
And you can switch over, say, from Microsoft Azure to other platforms or from GitHub to Visual Studio Team Services for the location of where those files are.
Exactly. And one other good thing is you can do this for Linux or Windows.
Yeah.
It's not just Linux or just Windows. So you can have you can be using just one product for all of your infrastructure in your company. And just to add something to the Azure Resource Deployment part, ARM templates part, we also have this thing called custom script extension. Basically, when the ARM template is running, you can just ask ARM to run another script. It can be either a PowerShell script or a shell script. So if you want to install Apache server, for example, to a Linux virtual machine, you can just say, okay, go install Apache. So you have options. That's the good part about infrastructure as code. You're not just locked in using some product or some vendor or some process. You have options. But one thing we are trying to advise to companies that are starting their infrastructure as code journey, decide on something. So yeah, in the first phase, you will be, evaluating products, what I want to use, Chef, Puppet, product X. Give it a time, but after you decide that, keep using it. Because if you have separate products, then you're going to maintain separate environments for the products. You need to train your staff for separate products, etc.
And we have another episode coming up for configuration management.
Exactly.
And we're going to get into this configuration of what runs inside the infrastructure that you're creating as well.
Exactly. Today we are covering how you are deploying, how you are creating the infrastructure. And in that episode, we're going to talk about how we can prevent configuration drifts, for example. How we can make sure that something is always installed in your servers, for example.
Just duplicate.
So normally, when you install a virtual machine, you can run a shell script with Azure Resource Deployment or just separately. Here's an example shell script here. So it just installs these packages here like Java, JDK, JRE, MongoDB, Tomcat, and wget. And then you can see that it does some stuff. So it's basically creating an application environment called Parts Unlimited MRP. This Parts Unlimited MRP application is in GitHub, so you can just go to GitHub and fork it and use it. But this is not very handy for us because every time we create a virtual machine, we need to log into the virtual machine, follow these steps, and take a look if the steps succeeded. This is a burden for IT operations. We want to have automation. By automation, I mean I do not want to log into these servers to see if the script has run successfully, if there's a problem. I don't want to go into logs, etc. So I just want to give a product like Chef what I want to do, and Chef will act like a proxy on behalf of me and do this in my endpoints. So instead of running the script manually, you can create a Chef recipe or Chef cookbook. Basically, you convert your shell script or you convert your workflow into a Ruby file. Chef uses Ruby, so you can see that the packages, the shell script is doing exactly the same in Chef. Or you can do this with Puppet. The Chef and Puppet, the idea behind these two products are really similar. So you have a centralized console that are connecting to your nodes and deploying infrastructure. And this is, again, my Chef recipe to deploy this application. And what you need to do is you can have a Chef server. And you have options to even deploy Chef server itself. You can either use hosted Chef, which means you just sign up and start using a Chef server maintained by Chef company itself, or you can deploy your own Chef server, and we have a ready marketplace image in Azure. You can just go to marketplace and search for Chef server. You can either use your own license or you can just use the licenses coming with Azure, and same is valid for Puppet as well. It's really simple. It's just like creating an Azure Resource Manager deployment. You just decide on the name, number of nodes, etc., and it just starts running. Here's my hosted Chef server. So I have organizations. So you may have different infrastructure for different departments. So you can just create different organizations, or you can even have different companies being managed by the same Chef server. I'm not going to go into the very technical deep details of this, but here you can see my nodes. So I installed, you can think of like I have an agent running in that nodes talking back to my server. Like in every X seconds, you decide on how many seconds, like every 60 seconds it connects to the Chef server and asks, hey, do you have anything new for me? Do you want me to deploy anything? And it is not just limited to features, packages, etc. in the VM. You can also deploy Azure resources like Azure virtual machines, storage accounts, etc. So by using Chef or Puppet, you can just create your environment from scratch automatically. You don't have to do anything. And here are my nodes. You can see that the uptime, last check-in, things like that. And basically, here is my Chef workstation. This is the command to bootstrap a node, meaning you don't even have to install Chef agent to the endpoints by logging into them. I'm just using my Chef workstation, and it connects to my endpoints and installs Chef client, and then runs the recipe or cookbook. For example, the application I showed here. So it's that simple. And another good thing is you can do this for like 1,000 endpoints. You can just say, okay, I want NTP to be installed in all of my Ubuntu 14.04 virtual machines in my environment. Let me show you an example file for Puppet as well. It's really similar to Chef. You can see that you are in charge of everything. You are in control. You can even decide that, okay, I'm going to use one workflow, and I want to decide, I want to use it for different distributions of Linux, for example. The NTP package is named differently in different distributions, so you can even say, okay, if this is going to be run on a CentOS or Red Hat machine, go install NTPD. If it's going to be on a Debian Ubuntu machine, go install NTP because the service name is different. So this is really flexible and gives you the option to deploy things. And here's how you can deploy virtual machines, Azure virtual machines with Puppet, using the Service Manager, the classic mode, and also the Resource Manager mode. So Puppet can connect to your Azure subscription and use your Azure subscription to deploy infrastructure automatically. This is really important because one of the other benefits of infrastructure as code is preventing human errors. I mean, this is maybe the coverage of love songs, but really, people make mistakes. Even if it's a very simple thing like, okay, I'm going to log into my server, change the name of the server, add it to another domain. You know IT, you know the daily life of operations. It's like firefighting all day long. So somebody can just come and say, hey, we need you right away. Just leave what you're doing and come with us. So you go, and when you're back, you just miss step 2. It's a very simple thing, but you may miss. These products, they don't miss a step. If there's an error, it just tells you there was an error in step 3. Here's the log. So you can just check the logs. Is it a certificate issue? Is it something else? And know what's happening in your infrastructure.
Yeah, some pretty big consistency and time-saving benefits.
Exactly. So yeah, this is basically how you do things with Chef and Puppet. Again, it's not just Linux, it's Windows and Linux. So you can use these products or Azure Resource Manager to deploy different products to Azure or even to your on-premises service. You don't have to use cloud. You can use your on-premise infrastructure to deploy resources. So it's really one of the very basic and foundational steps that any company should take because it's beneficial for both the developers and operations. So start small. Don't try to go big and do everything at once. Like I'm going to automate my whole infrastructure. I'm going to just click a button and everything will deploy. No, baby steps. First, try to understand how it works deploying virtual machines. Then try to understand how it works with deploying something else. And then you can just move step by step. Of course, the final destination is hopefully automating everything. Using infrastructure as code for everything. Okay. Yep, that's
we'll
it.
Switch to slides.
Sure.
All right, so the last slide here, we're almost done. You can see you have quite a few options there with infrastructure as code, and this area is growing quite a lot. So you can look into those. Finally, we have the same resources that we show you in every episode of DevOps Fundamentals. You can have a look at the hands-on labs. The last item here is the more important one that will take you through the Parts Unlimited demo that we showed today and help you go through creating the infrastructure both with ARM templates and Chef and others. A few others here. The DevOps Dimension show is another show that we have going on here on Channel 9 for you to check out, and a few other resources there as well for you to review. So keep tuned for all the other episodes that we have coming up for you. Thank you. Fundamentals. In this episode, we're going to talk about automated testing. It's a massive, massive topic, but that's why we have a good friend of ours, Chuck, here to help us talk through it. So just to introduce ourselves, I'm Thiago Almeida. I'm leading the series here. You can follow me on Twitter at NZThiago. And Chuck, do you want to introduce yourself?
Absolutely. My name is Charles Sterling. I'm a senior program manager on the Visual Studio team. Been with Microsoft for 25 years. By education, I'm a marine biologist, and as I was telling you, love fishing. So that's a little bit about me.
Great. All right, so when we were looking at where it fits inside a whole software development lifecycle, testing, it's basically everywhere. We have it there in development and testing, release and monitoring and learning because it sort of fits, depending on the type of testing that you're doing, it fits in almost throughout the whole software lifecycle. We've also been talking about throughout the series on mapping from an idea of DevOps, the practices, and then down to the actual technology that you can use to implement. So at a 100 level, if you're looking at streamlining the pipeline for frequent and rapid deployments into production with high quality, and I guess that's the key point here, we are at the 100 level, and then that's where the practice of automated testing comes in. And then from there you can map to a bunch of different tools and processes that you can use to actually implement that practice. Like we have there unit testing using Mocha or MS Test, or Selenium web testing or load testing, and etc. So that's what we're going to cover today. So here...
No, go ahead. You're on a roll.
On the automated testing part, that's where you run, well, one of them is unit testing. So you can run integration and unit testing automatically attached to a continuous integration pipeline or some other means. What are the types of testing that you would include in this section?
Well, so when we think about testing on my team, we actually think about it as 3 different workflows. And they actually really map to the persona or the people doing it. Now, automated testing, as it says here, is kind of your developer. He's the one writing the unit tests. He's the one looking for things like overflows. And he wants to reduce the cost of the integration by making sure that those tests run every time he does a check-in. So that way, there's no ugly surprises going out and saying, how come my methods aren't working because of my dependencies? So that's what automated testing is. And that's really around kind of that developer persona. But of course, we want to integrate that all the way end to end with the first slide that you showed in the DevOps cycle. So when we talk about the other two personas, we want to make sure that their efforts are integrated with the manual tester or the person who is actually going out and taking a look at it, doing the smoke test runs. And more, those people are looking and smelling like operations. Now, we can't cover that today. As you said, it's just a huge topic.
It's a mess.
But I think you should have either me back or a good friend of mine, Claude Rimrold, and we'll talk about dev test labs and integrating manual testing into that continuum. So that's two. So right, we've got manual testers and we've got test automation as for developers. And of course, my favorite topic is load testers. So usually these are the performance engineers, kind of a specialized operations team who make sure that the application is up to the right performance and actually has the capacity. So when the demos that we're going to walk through are going to go out and assume that the developer has actually got the stuff working on his box and he's ready for that next step. You went from the 100 level, I've got it working here, to it's now time to actually go out and do it at the team level with continuous integration.
Right.
And same thing with the load testing, is I'm going to assume that the performance engineer has gone out and figured out what the scenarios that they want to do. Because one of the first things that you need to do as a load tester is say, what questions do I need answered? How fast should the site work? How many users should, and they've already done that. And now it's actually time to actually test those hypotheses. A big part of DevOps is making sure that you've got hypotheses going in and you can validate those actually part of this. So, God, we've looked at, what, 4 slides, 5 slides?
Yeah.
It's probably time
For demos.
for looking at some demos.
So when we were talking before, you mentioned a big difference between the automated testing at the beginning and then the load testing from the other side. So one is the validation that the code and everything else is okay before it's deployed, and the other one is the checking the capacity and the performance of
Exactly
it from
right.
the other side.
Exactly right. And again, in some cases, there's actually a third pivot you'd look at is stress. Everything's going to break. It's also interesting, in addition to checking the performance and the capacity, is finding out what breaks. Purposely going out and saying, I'm going to find out where the code has got faults, and we're going to smash it until it falls apart, and then we're going to fix that part, and we're going to smash it again. It's a little bit different than performance, and it's different than capacity. Because capacity, you can work your way around it by doing what? It says auto scaling somewhere, I think, on the slide, or it did. Oh, here it is, right here.
Yeah.
I could actually, I could solve capacity problems by just adding a rack mount or a data center. Worst case scenario is a data center, right?
Yeah.
Stress testing goes out and says, within a constrained set of resources, where is it fail first?
Right.
So, anyways, does that answer your question?
Yes.
Yeah. Okay.
Great. And as always with these slides, we have the values there, more business-focused values that you can look into as well for both load and automated testing. So make sure that you pay attention to those. But I think now it's time for some nice demos.
Yeah. Okay. So as Tiago's been showing through his series, let's start with the demo app that I actually helped you guys write. So let's go ahead and Alt-Tab into the Azure portal. So let's go ahead and right off the bat, you'll see that in the planning phase, I can actually start getting some information from my application insights. And this is also goes all the way back to the last one of my monitoring. Right. This tells me that something happened here where my server response time was actually much slower. I would want to go out and start drilling into that, but that's a monitoring session. I think you're actually going to talk to Raul about that later in the series.
Yes, we have another APM session.
Okay. So I'm gonna not steal any of his thunder, but I'm gonna go out and say, I want to know what's happening there, or maybe I can replicate it and take a look at those particular pages, because I actually know what deployment was made here. I can take a look at that.
Right.
So let's go ahead and take a look at the app, and maybe actually put on maybe a bit of our manual tester hat, just briefly, and take a look at it. So this is the Parts Unlimited website, and I can go ahead and see if it's running right now. By the way, this is a live URL, and a lot of people are deploying to it. Me and Tiago have got a lot of helper bees that go out and do deployments all the time. So it's not always that we hit the URL and it's running and it's up. Sometimes it's down, but those will actually make just as interesting sessions, because we can go out and say, let's figure out what's going on.
Yeah.
I'm a tester at heart, so we go out and figure this out. Now, The page that actually I thought was actually having problems was our recommendation service. Let's go ahead and go back in the Azure portal and go into our tools menu, and you'll actually see something that my team's been working on to enable the operations team to go out and validate the performance. And you'll actually see that there is something called performance test. That wasn't there that long ago.
Right.
And it says that there is no test found. Well, we need to fix that. Obviously, I haven't been playing with this, just coming back from the New Year's. So I haven't actually been playing with this for a little bit. And it's saying, what URL do you want to use? And you'll notice it
Defaults to
pre-populated.
the website.
Yeah. And it defaults to the website URL. Now, in the next couple of sprints, I don't think this is NDA. I think I can tell you, among friends anyways, that we're actually going to give you multiple options here. You're going to have a drop-down of some of the URLs, if we can actually identify those. We're going to be using application insights to actually figure out what you're going to, what you're looking at.
Right.
And then also be able to import web tests that your performance team has created. So your operations team can go out and say, hey, let's look at that shopping cart scenario. Let's load that and figure out what our performance is. And let's go ahead and name this. I don't know that we're going to take a look at it in Visual Studio, but we'll call it Tiago. Apparently your name's got a P in it today. The West US is actually where I am hosting this application, so it's defaulting to that location. My user load, now our SLAs that we established with our good friend David Tazar is that we should actually have this application support 500 users at least with a, I think we decided like a 5-second response time.
Right.
So what you saw right there, guys, I don't know if you saw how long it took me. I don't know, was that about 30 seconds?
Yeah.
And I was chatting and spelling the names wrong. I created a load test to make sure that a endpoint was actually meeting an SLA. Oh, it's queued. Let's go ahead and open Tiago up. And what it's doing at this point is going out and actually spinning up a Azure VM, putting the agent in it. So this is important that I actually reiterate what has happened. It's a new VM that we actually have got that agent running into. So that means if you run a load test and somebody else comes off later, it's not going to see any of your assets that you put up there.
Right. And that's the the load testing agent.
Actually, it is the load testing agent that we run for the cloud service.
Right.
We're looking at actually doing things like making that available to your subscription. That's a little ways out.
Okay.
So, but yes. So anyways, why don't we actually, this will probably go for a couple minutes. Actually, the longest I've ever seen it take about 3 minutes. But I don't think we want to wait 3 minutes for this to
we
come
can
up.
come back to it and
I was going to
check
say,
it out.
typically I have one already ran.
Yeah.
But I just didn't prepare this. So what we're going to do is we're going to come back in a second. Now the thing from this is I want to go from that manual tester, and I actually want to show you how I would actually put this into my CI pipeline.
Right.
And show you how I would take the developer resources and put it in that same CI pipeline. So let's go ahead and take a look at taking these exact same assets and actually put it in our release pipeline. So what I actually went to is a new tab on my partsunlimited.visualstudio.com. This is where we actually do all the check-ins and the building of that application. And what we'll see here is actually I've got a build tab itself. Now I'm in a team project called Corey's Parts. Do you know Corey Fowler?
Yep.
Okay, so me and Corey, we're actually got our own separate branch, and we actually been playing with PHP versions of this. So something for you to know is that we actually have a PHP one out there. And you'll see that I've actually been playing with all of these TR builds for all day. Actually, you'll see that I've been playing with this the last 10 hours, it looks like. But we're going to go out and create a brand new one. And I'm not going to start with any of these. This is kind of cheating. I want to show you how we actually got to this. So I'm going to start with an empty one. And what this is doing right now is asking, since this is a Git repository, which branch of your Git repo are you working with? You know, the Parts Unlimited's got several different branches, like the 4.5 branch and the 5.0 branch. In this case, me and Corey were working in main, and we're going to continue working in main. And I could even actually check this checkbox right here, but we're not. I'm going to show you again. I'm not going to cheat. I'm actually going to show you where that is at in that build definition itself. So let's go ahead and add that step. Now, this particular version of the Parts Unlimited application is a Visual Studio project. I know that you guys have got a Java one that you built, but that's not the one that me and Corey are playing with. So I'm going to go ahead and build that. And you can kind of see that it's snuck in there behind there. It's one of the things that always catch me out is the fact that you don't see it popping up. The next thing that we want to do is go ahead and run those unit tests that our developers have written.
Right.
So you go ahead and add that Visual Studio test. And what these are, actually I don't know that we're going to take time out to show those are, is that test, this test, let me highlight it, is going to run on the build agent.
Right.
Right? So if I had 100 unit tests, it would run it on the build agent.
So that's the unit test.
Those are the
ones.
unit tests.
Yeah.
And actually, I can go ahead and, you can't quite see it, add a filter to say which unit tests. So I could go out and add those, or only run those unit tests for shopping cart. So I can actually add the shopping cart criteria. Now, if I wanted to go out and run across 1,000 machines, for instance, I would actually use the test agent deployment task to push this agent out across probably a whole bunch of brand new VMs that just got spun up. Yeah, maybe 25 Chrome-based machine, 25 Firefox,
Right.
and 25, what's the other browser called?
Edge.
Internet Explorer, Edge. Yeah, we'd have 25 of each. It's only 75. Whatever, you get the idea. So I actually have got a bunch. And then what I would do is go out and add this test agent that says I want to run it across those, and I actually would run all those that have the tag of Chrome, on the Chrome ones, all those with Firefox, etc.
So for those two, there's a little bit more of prep work to have those machines waiting for it.
Yeah. And there's two different ways of actually having those machines allocated. I could go ahead and say I want to use all the machines in a resource group. You know about resource groups. Or if you're an on-premise customer, which is most of our customers, they're not going to have a Azure resource group of test machines. They're going to have a lab full of them.
Yeah.
What we have there is, let's go ahead and close this and I'll actually show you, is if I go into, see if I can get a right click and open a new tab. I can. A lot of times my right click is my left click and I just go there. I can go into machines. I can go out and add a new machine group, and I could call this one Tiago. And as you can see here, I'm going to reference these with a certain set of credentials.
Right.
And these could be overridden at the test agent level. I could go out and say, here's the default, but those 25 machines that I'm running Firefox on actually require a Firefox specific.
Right.
So maybe call this one demo. And in this case, it may be, oh no, it's actually, a lot of our dialog boxes are clear text for the password. And the reason being is we expect those to be variables.
Right.
And I always forget which is where. And of course, the way I'd reference these 25 on-premise machines that already exist is I'd actually put in their fully qualified domain name or their IP address.
Right.
So let's go ahead and just call this one Tiago.fishing.com. I spelled phishing wrong too. And again, this is how I'd reference lots of machines, install the agents in them if you didn't already have those, and then run tests across those. But let's go ahead and go back to our build agent that we've already got. Now, this first argument is saying if I have multiple solutions checked into the repro, which one do I want to build? In this case, the Parts Unlimited just has that one solution in the root. So actually, we don't even need to change that. The next one is going out and saying, what MS build arguments would you want? Now, typically in our scenarios, the one that you want, do you know which one we would usually add here?
Package.
Add in the package, absolutely, guys. So what Tiago's talking about is at the end of a continuous integration, he would want to do a deploy. He's kind of got that operations look and feel about it. So he wants a package that you're going to push out.
Yeah.
So you do like a /p:/, and then the package arguments. Okay. At this point, I think we're good. And this is actually going to run all of the tests that are already in the solution. Let's go ahead and set up that trigger. And we're going to go ahead and set that up to be a continuous integration. Now, this is actually something that's worth showing out right off the bat, is the fact that this is scheduled. One of the things that people want to do with load testing all the time is schedule a small load test, almost as an availability test, to run nightly at like 2 a.m. You know, they don't know if someone's added a server or someone's changed a switched or someone's done a check-in, but they want to make sure that their SLAs for performance hasn't fallen below some threshold. And they pick a low time so it doesn't impact their customer experience and say, I'm going to run that 250 users and see if we actually have fallen below our SLAs.
Right. So in this case here, that schedule for continuous integration kickoff of this. You can do both continuous integration for every check-in, but also you could have a separate build definition just for a load test that you want to run on a schedule.
That's right.
As well.
Yeah, so this one's going to run at 3 a.m. it looks like, 5 days a week, and it's going to run on every check-in. So let's go ahead and save this. Save is up here. I always want to look for save down here. Okay, and we're going to call this one Tiago 1. Maybe we'll create more. Okay, and at this point, let's go back into our code. And we're going to go out and make some change. So now these are actually the notes for Corey. You can actually see what I've done is I've listed a set of different notes for Corey.
Yeah.
But since this is actually part of my repo, if I edit this page and I save it, saving it does a check-in, and it should actually do the kickoff. Best of luck for, your demo. Okay. So we worked together on a demo that he was actually doing at PHP World. I think it worked out well. He didn't get fired, so it must have been okay. Now if I go back to build, this is always scary to work in a pre-existing project because you have no idea. See all these build definitions? I have no idea how many were actually CI.
Yeah.
So again, a lesson to new players, work in your own branch. That would actually obviate this problem or alleviate this problem. And also verify that your trigger is set up to your branch.
Your branch, yeah.
I don't know how many times I've seen where people go out and say, my build isn't kicked off, or I got 5 of my builds and I haven't done anything. Both of them are problems. Or the ones that we run in classrooms is we might have 25 people and they've all done check-ins, and people will say, I know I'm working in the main branches as everybody else. I see theirs, I don't see mine. So let's go ahead, and you can see these already there. I'm going to go back to that trigger. Tiago is actually the one we're playing with. And I want to show something that people may not have noticed is under triggers, there is one actually that says batch changes. So if you're not seeing your check-in as a discrete build, it's because the default is batch changes. Yeah. If you want that behavior, just uncheck that, and it makes it very simple. Okay, I promised you a little bit of manual testing, and I showed you that earlier. Hopefully that will actually work off, manually kicking off a load test, some continuous integration.
So inside the continuous integration, that Visual Studio test step, that's what's going to run any MS tests that you might have inside your code, or I guess if you had XUnit test there, then it would trigger those.
Yeah, well, let's take a look at that. That's actually a great point. So if we go out and we're looking like we're still queued.
Yeah, we're next.
We're next. We're going to go ahead and let's go ahead and take a look at all the builds. We'll actually see one that is run. I think the other one that was just run a second ago was called Insiders 2. Yeah, right here. So let's take a look at see what the heck was Insiders 2. And you'll see the test results that you were talking about.
Yeah.
So right off the bat, you'll see that we do not have for that Insiders 2 a build on build change. That there were 20 passing and
2 failed.
And 2 failed. So the net is actually the fact that we're up 20. Actually, so it looks like everything is a net new. There wasn't an old Insiders 2. So I had to think about that. So this is build on build deltas.
Right.
Not overall changes from day 0. And
so if we triggered this build again and one more failed, then you'd see the delta between this having...
That's correct. It would actually say, it would say 0 here,
Right.
but the 20 up above would still say 20.
Right.
So this would say 0. So I'm glad one of us has got this figured out. Now, of course, what we've done just before Christmas is we actually added the test results, the build results dialog. So this wasn't there a little while ago.
Right.
And matter of fact, in probably 2 more sprints, you're actually going to see a code coverage tab show up here. So you can actually see your code coverage. Right now, it's a separate set of HTML files that you actually have to load. But you can actually have this as a hub right here. If we go ahead and maximize this, let's go ahead and take a look at what's here. You'll see that I had 2 of what looks to be my Selenium Internet Explorer tests failing. If I go ahead and take a look at my test run, let's take a look at these. You can see that this is the error message. I get the stack trace itself. There was no linked bugs, which means I probably want to go ahead and create a bug for this. And you'll see that all of the information that you need, what test run, which build, which check-ins, what error messages, including the title is already populated. All I have to do is hit save. I mean, it doesn't get much easier than that as far as going out and actioning a rich bug. If I go ahead and close this down and take a look at this test run, this takes me into my runs, and I can go ahead and see what looks to be similar data, but if I take a look at my test results, you can see the breakdown of all of them, and you'll see those two that failed. So it looks like all of my Chrome and Firefox ones are working, and I only have problems with those two Internet Explorer ones, which would either let me kind of clue me in that I need to take a look at those particular machines running it, or take a look at that particular code.
Right.
So it actually starts giving me a trend where I've got particular problems. Okay, so this is taking my unit tests, putting it into a CI pipeline, and reducing that cost of integration. You know, right now we defer it and it gets monumental. It grows and grows to where it's very, very expensive. The other thing I wanted to show you guys is going back in here, is showing you how you could actually do that load test.
Right.
If I go ahead and go back to my Tiago 1 and edit this, so it failed. So if we take a look at it, we have the exact same set of results, which makes sense because it was the same check-in run, the same set of binaries. And the reason it failed is because I had those two failures.
Yeah.
So what you'd want to do is edit this.
To continue even if it fails.
And continue on error, exactly. So you've done this a couple of times. There you go. So now what you're going to see is instead of a fail test, actually a warning test.
Right.
That says that you completed, but you actually had some warnings.
Cool.
Now what we want to do is go ahead and add a build step. Go ahead and you'll see that there are three types of load tests. There is, let's actually add all three of them. And matter of fact, this one may not be in your guys' accounts. So this is something that is brand new that we'll be showing off today. Let's add the first one. I think I added all three. If I didn't, let me know. So what this one is that we just added, working with a company called Soesta.
Soesta, yeah.
Do you know Soesta? All right. Soesta does amazingly good load test tools as well.
Right.
Just like Microsoft. And they have a great following in the Java and the cross-platform community.
Right.
And the last thing that we want as DevOps team is having a development team saying, you know, I can't use that whole Azure Visual Studio thing because you don't have support for fill in the blank.
Yeah.
Maven, Jenkins, Grunt, Soesta.
Yeah.
So working with Soesta, they're like, well, we don't want your customers to not be able to use us.
Yeah.
So they've actually gone ahead and added their own build task, and you'd go out and reference your Soesta connection that you've already got. This is both authentication mechanism and a billing identity.
Right.
Okay. And then finally, the composition name. The composition name is exactly like one of our Visual Studio load tests, where you go out and specify which web tests you want to go, and actually which mobile tests in their case.
Right.
So
I noticed there's mock-up testing steps there. So just like for load testing, we have support for other load testing tools. We don't only have Visual Studio test options there. If you're just running JavaScript and you have mock-up tests inside of your JavaScript code, you can also add the step there for.
Absolutely. One of our primary driving principles is to let you use whatever testing framework you're already using. You saw that in my tests, what was failing, Selenium tests were actually being run.
That's right, yeah.
So I actually reference those for my unit tests, which is certainly one way of doing it. If you have Selenium Grid, you can reference that. And then we actually have a publish. If we don't even know what kind of test framework you have, you can still go out and shell it back to them and publish those results as part of your build. So again, JUnit, NUnit, XUnit, Selenium, we run them all, and we actually should provide a better flat platform from doing that.
Great.
Okay, so
back to the load testing.
Back to the load testing one. So we actually have two that we supply from Microsoft. The first one is a quick web performance test. And this is saying, just like the Soesta one, which Visual Studio Online account do you want to have the build go back into, and which one am I authenticated using? So I'll use this, this Parts Unlimited. I will go ahead and grab this URL. Why didn't my copy didn't work? Oh, there we go. And wrong place. Oh, look, it worked.
It did run.
Okay, we'll come back to that in a second. So we can find the right build. Here we go. I'm going to give your poor viewers Tourette syndrome walking through all these different tabs. The test name is actually a way for you to go out and start doing reporting and comparing these. So if you remember, I named it in Azure. So I can run a test in my build, I can run it in Azure, and I can run it in Visual Studio, but I can compare all three of those.
Right.
So if it's, you know, something that your operations team ran in Azure, they might want to say operations 1. And us, we'd go out and say CI load test 1. So I know that it came from a CI build,
right,
etc. Again, you'd probably do more descriptive than this.
So is this the same as the one that we triggered from the Azure portal?
This is the moral equivalent to what we just showed inside of Azure. Cool. So again, whether or not you do it inside of, I can show you it inside of Visual Studio Online, inside of Azure, or inside of Visual Studio, or inside of my CI pipeline, I can actually generate those load tests across all of them and run comparison and trend analysis. Use the tool that makes sense for you, but make sure you get the same quality shoved back upstream, making sure that you're meeting your performance SLAs. Now, in addition to this way of looking at simple URLs, we actually have a way of referencing scenarios. So if I want to reference, maybe it's 8 web tests, I do a check-in, I add a product, I do a checkout, I calculate the tax, and these are all different web tests that I'm using in series, or actually maybe in parallel. I can run these in parallel as well. I'm going to go ahead and reference those in my repo. So let's go ahead and reference the exact same subscription. Take a look in my repo on my local test settings file. And while I'm here, I think I have a load test in here. I just want to make sure what it's called. So my load test is called homepage.loadTest.
Right.
So let's actually, while we're here, let's just cheat and copy. So that's my load test, what it thinks is the default, which is wrong. I have my homepage load test. Oh, actually, this, did I not hit, I must not have hit OK. I must have hit escape or something.
No, that's the folder.
Oh, thank you. Yeah, you're absolutely right. So let's point to the right folder. I'm glad, again, one of us is paying attention. And the reason you point to that folder is because your web tests are referenced by the load tests.
Right.
And it's going to expect them there. And then also your load test settings file, which is actually this first one, will have batch scripts for doing cleanup, tear down, fix up, etc. for your load tests. So again, it's going to expect those to be under that directory.
So these are all load test files that you created in Visual Studio.
I did.
Then saved that as part of the code and then checked it in.
And then I checked it in.
Yeah.
That's right. And again, we are going to offer a richer authoring experience. That's a little bit awkward to say. In both the Azure portal, so you can actually reference multiple URLs, or JMeter.
Right. Yeah.
I don't know if you knew that or not. We're actually, I think it's actually enabled in this. Let me show you that. A little bit of sneak preview for your users. In addition to web tests that I already told you about.
Cool.
So let's go ahead and save all of this. And as you would expect, if I go out and do a check-in, I could kick all of this off, and they're going to run through. And of course, this last load test, I think it's actually set up to say run for like 10 minutes. So it's going to take a while. And probably something that you want to do intentionally, and maybe not something you want to do as a CI pipeline, but probably more something as a CD pipeline, where you have a test environment with a manual approval.
Right.
Have you gone through the release management stuff yet?
We're going through that next with Donovan.
Donovan, great friend of mine. Matter of fact, if you look on my screen right here, I don't know if you guys can see the screen, I actually have one of his stickers. The reason I was late coming over here, I was just talking about it.
Okay, great.
Okay, so let's go ahead and take a look at this one that ran. So right off the bat, scroll down, actually scroll over and scroll down, and you'll see that our average response time is 2.8 seconds for all of these until something happened here. Any idea what happened there? that's when we kicked off the build. We did the CI build,
right.
and what was running at that point was all of those unit tests. So we saturated our poor web server, and now we went from a 2-second response time to 21.
Right.
But overall, this is telling us that the code that the guys have done have got, a 2%, a 2-second response time, and those failures didn't occur until actually we saturated the box.
And the SLA was 5 seconds.
The
so
SLA was 5
good.
seconds for 500 users, and I think that's what we're running, was actually 500 users. So David Tizar and the team that actually helped us build that Parts Unlimited application, I think we're there. I know that when we were early on, we had some issues with some of the controllers.
Yeah.
I think the recommendations view was taking a long time.
Right.
And we ran all those down. So again, CI integration with performance and unit testing really went out and showed us without any additional work where the problem was and what we needed to do to solve it.
When we covered the APM, the automated performance monitoring, we're going to show the recommendations tab and how you would go about finding out why it's taking so long to load as well.
And I would have expected to actually see another shark fin right here for that. And what's happened is probably the same latency for the spinning up that unit test. We're actually just seeing right here.
Right.
Otherwise, you would actually see a shark fin exactly like that one going all the way up to 21 seconds.
Yep.
So again, I had a great time.
Yeah.
If you can have me back and we'll walk through the manual test stuff, I would love to do it. Oh, I know. I promised to show you the JMeter. Yeah.
Yes.
So if I go ahead and go into test, you'll see that load test is now underneath the test hub. It wasn't there before. So this is now getting moved to one place for all of your test assets. Whether or not you're a manual tester, you're looking at test automation runs, or a performance tester looking at your load tests, you'll see that two things are going to come out as brand new. First of all, I can take a look at all of the runs that I've done. Oh, there we go. I was going to say, where are my runs? And you'll see that I have done 4 runs since we've been sitting here, or since we've been, actually no, a couple of them were 24 hours ago.
Yeah.
Some of them were a couple days ago, actually. And I can go out and say new, wait for it, Apache JMeter.
Right.
So
Cool.
you're not going to find this in your accounts, but if you are using JMeter and this is something that you want, email us. We know how to hook you up. It's my team. And we'll enable this feature flag. Have you talked about feature flags?
Not yet.
Okay.
Yeah.
So we'll enable a feature flag on your Visual Studio account. So when you log in, you'll actually see new, and you'll actually see Apache JMeter, an exciting new offering for the load tester and the DevOps team.
Cool. Yeah, we're going to cover feature flags in the advanced topics episode as well.
So with that, I was actually going to hand it back to you, if that's okay.
Yes. Yeah, so as from that you saw, we covered quite a few different types of testing. The main one was unit testing that we put into our pipeline, and then we also covered load testing as well. So thanks, Chuck, for those demos. They were pretty cool. And as usual, we have here a list of resources for you to check out. The key ones that we wanted to call out are the ones at the end there. So one is the hands-on labs that we have for Parts Unlimited, aka.ms/partshol.
I was just looking at these. Definitely worth checking out.
Yeah,
You guys have done a
they're
great job with those.
And there's a couple of testing ones there, so definitely check them out. And then we also have 2 URLs for you to go and check all of the test content that we have from Microsoft for you to look into, aka.ms/vstest, and another one, aka.ms/vstest content. So check them out, and I think that's it from us.
Tiago, thank you for having me aboard.
Thank you, Chuck. That was great.
Yep, senior technical evangelist focused on DevOps.
Cool. So do you want to take us through your
Yeah.
idea of DevOps and where it fits in?
Yeah, high level. We watched the opening intro about what is DevOps, but where we're at right now and how it relates with continuous integration DevOps practice, it is roughly around the develop phase, right? So after you've figured out what are we going to develop, and you start to do some coding, at that point, continuous integration is really relevant, and we'll get into what that is in a second. But naturally, dev and ops should be involved across the entire life cycle to really be doing DevOps. CI is a little weird for an ops person, right? To be honest, an ops person is kind of like, huh? CI, you're checking in code? What? But we'll get into that here in a second. So yeah, let's move on to the next one. So just to kind of position what is DevOps practice, how does it fit in? You know, we've given you in a previous module the high-level overview of what is DevOps, and at a 200 level, you know, it's these DevOps practices, continuous integration being one of them. Connecting that with individual technologies. There are a ton of different ways on how you could go and implement continuous integration. We are going to show you, of course, Visual Studio Team Services as kind of the backbone to enable that, but certainly we have a lot of possibilities. As you can see on the slide, you could use Jenkins, connect that to Visual Studio Team Services. You could use GitHub. You could use different version control systems even, TFVC or Git. A lot of possibilities, a lot of combinations that we have out there.
Yep.
Yeah.
And at the 100 level, one of the DevOps practice or the idea that we have that sort of fits in with continuous integration is the continuous delivery. So it's one part of that flows all the way through.
Yeah, it's a subset of continuous delivery for sure.
Cool. All right, so let's dig into continuous integration a little bit more.
Okay. Starting with the people down there. So what role would a dev and an ops person play in this overall process? We'll get to that here in a minute, but I would say an ops person, you know, should be at least familiar with this and get the output of the build, in this case of the continuous integration. But at its there's kind of I like to say, a loose and a strict definition of continuous integration. And the kind of liberal definition of continuous integration, some people point to, is you check in some code into source, and right after you check that into source, a build happens. Now if you click again here, we can see that also you get a little, now one step closer to the more conservative side. You're going to also run some form of tests, and there's even more things if you can continue down the path of being more strict or more conservative on continuous integration definition. I would say, in my personal opinion, I would say that continuous integration at a bare minimum should include checking in code, doing some unit tests, and that's like the minimum bar.
Yeah.
But really, what's this going to help you with, right? This is going to help you to accelerate your delivery. So there's no longer, you know, I've been to companies where they have somebody whose job is to do the build. And you ask them maybe, oh, do you have automated builds? Well, yeah, we have a script that automates them. Well, how does that work? We have somebody who goes and does it. Well, then it's not automated.
Yeah.
Right? It's not automated. So, you know, you don't want the person to be the bottleneck here, and there's a ton of systems to help with that. It's going to help you really, you know, accelerate your delivery and have a repeatability experience. And so at any point in time, if anybody wants to know what's the code that was checked in, did it work or did it not, you have the latest build. Everybody has access to the latest build or bits of the application.
Right. And another part of continuous integration, or I guess another extension to the definition, is that you would have to work with this accelerate delivery value, is you would have a build that is ready to go to production. Of course, it doesn't have to be every check-in for every feature that every developer is working on, but having the mindset that quite often, or even at every check-in, depending on at what stage you are in, you would have a build that has been built, tested, and you know it's ready to be taken through the stages and go all the way through to production. So if you look at the other module that we have, continuous deployment and release management, that's what happens after you have continuous integration.
Yeah, and you know, in terms of what types of tests, there's all kinds of tests. I would say right here is where you should have a unit test. Typically, that's what people put in here.
Yeah.
You technically could have other tests. It's possible, but not likely you would do much more than unit tests in this space.
Yeah.
And in terms of measuring that, I'd say the most important factor here of you know, once you've implemented this practice, what you would know has changed would be the lead time. And lead time being going from new feature to that feature is in customers' hands in production. This is going to help with that, right? Because if, you know, for instance, if you have a manual guy waiting on there, that's going to slow your lead time down, and that would be one part of the overall systems thinking that would help the overall picture here, right? And then meantime, MTTR, mean time to repair, would be like you've got a quicker way to do the build to push perhaps a fix into production. You could push out a fix faster. That would be another way.
Yep.
But yep.
All right. So, like the other episodes, it's demo time.
Yeah, let's see it.
Okay. So I'll go here and go straight into Visual Studio Team Services that we've been using with the Parts Unlimited sample. And one thing that you can do on the Build tab here is create new build definitions. So if we create a new build definition here, right from the start, you can see we have some templates. So I'll use, for example, Visual Studio. And the repo type. So I'll leave Git, the repository, and the branch. So if you're a developer that you're working on your own branch, or you're a feature team that you have to have your own builds before it gets merged into the main branch, you can choose which one you want to build from. And then finally, you can click the continuous integration tick box. So if I click create, that's it. We're done with the show.
Okay, that's it. We're all finished.
All right, thank you. All right, no, we were just kidding. There's a lot more to it than that.
So as you can see, continuous integration has changed quite a bit over time, and that was an example of people thinking that they can just check a box and be done. And perhaps if you really want to use the extremely liberal definition of continuous integration, then okay.
Yeah.
But there's a lot more to it than that, right? I mean, for testing, for instance, being one of them. So maybe you can show us a little bit about that.
Yeah, so here in the definition that it created for us, you can definitely add a whole lot of different build steps. A lot of them are test related. And of course, if you have XUnit, NUnit, or MS test types of testing, you would run them from here. At the build stage, you can do not only Visual Studio based or MS Build based ones, but all sorts of builds like Gradle for Java and Grunt to run some task runners for your JavaScript code, and Gulp, etc., and Maven as well for even more compiling and building.
Yeah, the thing, at least the way it is right now, that's not very obvious is that you can, any of your different test frameworks like Mocha or JUnit or other things that you may be using, there's not at least today in the time there's recording, there's not a task that says that exactly. But if you look at some of those open source tasks such as Gradle, you'll notice that there is a option there to say export your tests up into our test system in JUnit format. So as long as your tests using those other types of frameworks output the tests in JUnit format, it should do the test through the core framework, Gradle, or Maven such as, and then the test will get surfaced as well as part of your CI build.
Cool.
Yeah.
And of course, here we have a building on a solution. So you can choose which solution file you want to build. This is for the Visual Studio one. And also at the end, you just publish the build artifact. So this is for you to use when you go to the next stage, when you're doing actual releasing into environments and etc. of your build. Another couple of options here, there's quite a few options, but one is what we saw when we created this build definition is to actually enable continuous integration. And you can, again, choose which branch. So, for example, if I come into Visual Studio here, go into the branches for my code, I could create a new branch. I'll create a new branch based on that one. So new local branch from here. Call it Chiago CI. So that's something that I'm working on separately. I'll create the branch. It created it locally. And then I can also sync it up, sync this branch up with the server side. So now we should see that new branch here under code. So I'll leave that definition there for now. And on the list of branches, I have my Chiago CI, which is just a copy of the other one. And you can see it saying that this build was never built. So now we can go into the build tab again and create a build definition that is based on that branch. So instead of master here, I'll just choose Chaggo CI, do continuous integration to build at every check-in, create that, and I'll choose my solution file because this has a couple of solutions inside. Click Save, call it Chaggo CI again. And now I have my own personal build definition that will kick in every time I commit to that branch.
Yeah, you did something there that I think is important to maybe do a little bit quicker of a deep dive in that, and that is that if you have in your source code a ton of different things under a single source code repository, a kind of a general best practice is to think about what's the smallest deployable unit that could be delivered independently that adds value to an end customer or user. Right? And that's going to help you if you figure that out. That's going to really help you to accelerate your delivery. It also has a lot of ties all the way back into your team structure, your development structure, the whole core of people, DevOps, right? Of having an ops person support different aspects. So there's a lot of stuff. And even though he said, "Hey, let's just build this one solution," there could potentially be a lot of rework in what you just mentioned, depending on how things are structured. And if you've got this monolith, huge repository thing, that's probably going to be a bigger thing you might need to tackle.
Yeah.
Before you talk about CI. I mean, certainly you could do CI and have it build 15 solutions or whatever, but ideally to have things a bit more streamlined, reduce your build times, and a number of other things, you're probably going to need to think about that for sure.
Cool. So just to finish that part, if we make a small change here, this here is a discount of 90%. I think it's a little bit high.
Go for it.
So
let's do it. Let's see it.
Let's do 100 and just give it
there
for
we go.
free then.
Yeah.
So I'll save this, and once I commit this change, so look at changes, it's showing, I changed or a massive discount. I'll commit this and push to the server. That should send it up to our branch. And if we go here and have a look at the builds for Chaggo CI, it kicked off a new build for that definition that we created. The next thing I wanted to show is branch policies as well, because this comes up quite a lot. Is if you go to manage the project and have a look at version control, under here, under the branches, I could click on my main one here, that's what I'm treating that one as, and go under branch policies, and I say, whenever someone creates a pull request against this, queue this specific build, right? And it'll block the merge if the latest build did not work.
Yeah.
So it's gonna try to build it, and if it fails, it's not gonna actually do the accept the pull request.
Yeah, this effectively is like a gated check-in, right? And when you are, we kind of have been dancing around this, but if you get into a real conservative or a strict, I may say maybe even more of a textbook definition of CI, one of the things that you're going to be doing is you're going to be checking into trunk every day. Everybody checks into trunk or mainline every single day, and everybody, that's going to fire off builds, right? If that is the behavior that you're doing inside your organization, then that is something that you probably don't want people checking in code that breaks all the time.
Yeah.
So this is going to be, when you're in that behavior, that's going to be extremely important that you have something like this to do the test before you allow the check-in.
Yeah.
And so yeah, it's pretty important that you get that. But I will say that mindset shift of checking in the code every day, that's a muscle that you have to really build, right?
Yeah.
It's not something you can snap your fingers and be like, I'm just going to check in every day. Especially if you're like, I build this feature for 2 weeks and then check it in, right? It's a bit of a shift, but it's a really important one that I'd say really goes beyond probably the scope of this module, considering we're talking about fundamentals, but it's at least something you all should be at least aware of and start to think about as you think about CI.
And if you want to get to that nirvana of deploying to production every day with changes that the team is working on, this is definitely the first step, the first mind change to implement.
Absolutely.
All right. So that was it from the simple demos, unless you wanted us to cover anything else. But from the demos perspective, this was it, kicking off a build based on branches, branch policies, and changing the mindset of your team to always be ready to commit to every day to the main branch and be ready to deploy to production every day.
Yeah, and also write tests, right? So if you don't have unit tests, that's also really important, right?
Yes.
Because, especially if you adopt this mindset, because sure, you could check in every day, and then if you don't have any unit tests, who knows if something broke or not, right?
So in our sample here, on the main branch here, for example, there's a few runs of the continuous integration build. If we go and have a look, we can see there were 36 tests that passed. Of course, that doesn't really cover the whole thing. It only covers 2% of my code.
So that's where code coverage comes in too, right?
Yeah.
It's saying, not that you have to have 100%, but if you have 1% of code coverage, then there's probably
you need to write a few more tests.
You pay now or pay later, right?
Yeah.
And that's the big thing, right? With testing is do you want to pay once it's in production, or do you want to pay up front here where it's fairly fast to get things fixed?
Yeah.
Because there is an overhead when you try and fix overhead and a cost when you try and fix bugs in production versus the developer just was working on it, just fix it, and he fixed it right away before it causes problems. So pretty important to to do that early.
So if you're watching this module now, make sure to also check out the one on continuous deployment and release management, because the output of the build that we're working on now then kicks into release management later. So check out that module that I recorded with Donovan.
Yeah, absolutely. And then maybe you can show us the resources for other folks if they want to dig in and start to play around and learn continuous integration on their own.
Cool. So we have this resources list here for you. The one I always call out is the one at the end, Learn DevOps Practices with Hands-on Labs. So the Sparks Unlimited sample that we have a list of different hands-on labs that you can follow. And both for this one, the sample that we're using is the .NET version of it, but we also have an open source Java and Linux-based one as well.
Yeah, so you can do continuous integration with a Linux VM using Grunt and Java, or use the Parts Unlimited where you use .NET, both connected to Visual Studio Team Services.
Yeah.
So check that out if you want to get your hands working on implementing this thing yourself. And keep tuned for watching the rest of the series. So thanks for tuning in.
All right. Thank you. All right. Welcome to another episode of DevOps Fundamentals. Today we're going to be talking to you about continuous deployment and release management. I'm Thiago Almeida, as from the other episodes, at NZThiago on Twitter. And I have Donovan Brown.
Hi.
Donovan, you want to introduce yourself?
Yeah, I'm Donovan Brown. I'm a senior program manager here at Microsoft. I'm responsible for DevOps on TFS and VSTS.
Great. And you can follow Donovan on Twitter there or on his blog at donovanbrown.com.
Correct.
Okay, so continuous deployment and release management, that obviously fits into the software lifecycle area of release. So we tried to cover in the other episodes where it sort of fits in continuous integration, and we also have this frame from a culture shift inside your organization all the way through to tools that you can actually use to implement some practices that are in between. So at the 100 level overview, if you think about the culture shift of getting your team to always deliver continuously, so continuous delivery, that cuts across multiple things that we talked about already. So continuous integration to make sure that your code is always up to date and built and passing unit tests, etc., all the way through testing, automated testing, and then now we're on the next step, I guess, which is the release management and continuous deployment. And that, of course, for us here at Microsoft, it maps into Visual Studio Team Services and the release management tools that we're going to see today.
Correct.
All right, so do you want to give us your take on continuous deployment?
Yeah, continuous deployment is the ability for us to use CI, then trigger a deployment of that code. So the goal is, as soon as a developer checks in code, we don't want them to have to lift a finger for that code to be built, to be tested, to be packaged, and then be deployed into an environment for them, right? So it's all effortless. So this animation will give you that type of, you're looking at how the code gets committed to a repo, and it can be centralized or distributed, which is nice about VSTS. We don't make you choose. So if you want centralized version control, you can use it with TFVC. If you prefer Git and distributed version control, that's fine as well. And then what we're going to do is we're going to compile it, we're going to build it, and we're going to package it for you in whatever format's necessary. And then that's going to basically tell the environment, hey, there's something that you need, and release management is going to say, okay, let me grab that and actually start deploying it for you into your environment.
Cool.
Yep. So the way that you mature continuous deployment to release management is continuous deployment is usually to one environment. It's usually dev, right? A dev wants to have that quick, what we call inner loop, to where yeah, it works on my machine, but I sure would like to be able to quickly vet that this is going to work on a external machine that I don't own that might not have all the dependencies on it and allow me to find those quick failures. So that's what we want continuous deployment for.
Right.
And I might do that before I commit to even the main repo, before I do that merge into master, so that I can say, okay, does my code actually work on an environment that's not my own? Okay, good. Now I want to go ahead and check this in and start that true workflow that's going to take my code from development all the way through into production. So again, we're going to take that packaged output, and we're not only going to deploy it to dev, but we're going to have gates, which we'll show you inside a release management demo here, of ways of going back in and not only deploying it, but testing it. And then waiting for approvals from individuals in their organization or groups to say, does the code look good in dev before we go ahead and promote that into staging, and then finally, hopefully, from staging into production. So that's what we're going to do, is we're going to kind of grow up the continuous deployment story into release management. And one other note about continuous deployment, you can actually do that with our build system alone. Right? Our build system actually has the ability to compile your code, run your unit test, and then deploy it to, for example, an Azure web app or to another artifact or to repository. And then what we do is, now that that's done, we need to take that and start releasing it down the pipeline.
So like the other episodes we have, if you look at on the right side here of the slides, we do have the value propositions, the business values that you can get from this, and of course different measurements that you can have as well, because that applies to the other DevOps culture change that we have, is to measure everything. So this is one of the, some of the measurements that you can have when you're doing release management across multiple environments.
Absolutely. Meantime to remediation. So as soon as we find that there's a problem, how quickly can we get a fix, not only corrected, but actually back out into that environment? So that's an MTTR. Obviously, how frequently can we get that value to our customers? Because that's the goal, right? The goal is to continuously deliver value to our end users. And we can actually measure how long it took us to have an idea before that idea actually was in the hands of our end users, right? So that's the kind of stuff that we definitely want to be able to measure with release management and these type of pipelines.
And if you've been following the series, you will hopefully be connecting the dots now that we've covered continuous integration, we've covered testing, and now we're going to do the next stage of deployment and release management into environments.
Absolutely. Looks like it's time for a demo, so let's go ahead and switch over. And what we have here is the landing page that you're going to get when you go to release management. And the first thing that we do is we give you an overview of all of the pipelines that you currently have in flight. And what I like about this screen is that it's a graphical representation, and it lets me know immediately what I have in dev, what I have in staging, and what I have in production. As you can see, release 27 is already in production. And clearly we have release 28 that hopefully has some new features, maybe some bug fixes in it, trying to make its way from dev all the way through to production.
Yeah, I made some changes earlier on to the code, so it got deployed to the dev stage.
Absolutely. So we're able to wire this system up, and I'll show you how you do that, how you connect this to our build system. So you get true continuous delivery to where you don't have to, okay, the build's done, now let me go find some tool and click some buttons. All you have to do is check in your code, sit back and relax, and let VSTS build it, test it, package it, and then give it to release management, who will then go and deploy it, test it, and then move it down the pipeline for you. So this is great. You'll notice that this one is a different color, and it also has this little icon here. This is letting the system know that we've kind of paused your deployment. And the reason that we paused it is because we're waiting on an individual or a group to come in and give their approval that the code can then move from one stage to the next. And if we go ahead and click on this, as we'll see, is that they're waiting on me. Right? So I have to come in here and evaluate the code and say, okay, do I believe that the code is actually ready to enter the staging environment? This is really, really powerful concept. Just imagine that you're a QA lead at an organization who runs a really exhaustive QA cycle that might be, let's say, 2 weeks long. Your development team hopefully is building code far more regularly than every 2 weeks. And as a QA lead, that doesn't mean that I want every single release that comes from the development team. Because if I'm in the middle of a 2-week QA cycle, I can't take new code until I'm done, otherwise it invalidates all my test results.
Yep.
I have to start all my testing over, and I still got to get 28 out, so I can't take 29 at the moment. So this pre-deployment approval allows me to have that opportunity to say, you know what, I'm not ready for this code right now. Let me go ahead and finish what I'm doing, and then I'll come back and I'll approve that, so that you can go ahead and deploy the code when it's time.
So this is, of course, a choice. You don't have to have those approvals in between the stages.
Absolutely correct.
It's up to you how confident you are with the automated tests that you have. If you have a QA team that needs to manually go and test things or double check that it's running well, then that's what the approvals is there for.
Absolutely, and you can choose on a environment by environment basis on where the approvals happen or if they happen at all. So for example, in dev environments, I'm usually pretty liberal. I'm like, hey, get the code into dev as quickly as we possibly can and get it out of dev as quickly as we possibly can. So I normally don't have approvers there. There is a chance that I'll put a post deployment approval because we actually have approvals at 2 different points in time. We have one before we touch your environment, almost like asking permission. Can I please put this code on your environment? And until you say yes, we won't touch your environment. Then we also give you an opportunity to say, should we now go to the next environment? Should we even go and try to get into production? And this is another example where I put my QA lead not only as the approver coming in, but also as the approver going out. Because if I have to stop and do some functional testing, do some exploratory testing, and I just find a huge list of issues, I don't want this code to even bother the guys who have to approve production. I want to go ahead and stop this code right now and say, this code is not of the quality in which we are going to put our name on, and then I can reject it and the code will just stop right there and not even inundate the people in production. Because there's a lot of emails going on, there's lots of alerts happening, and there's no point in having it go to production and then me having to get on a phone or email someone really quick, please reject that, right? Because I don't want it to go. It gives you the complete control. Now, I'm actually not going to approve this because I haven't seen the app, right? So I don't want to go and say it's exactly. So we're going to go and look around and see if I can look at the status of this release and see if I can get some confidence on if I think it's worth being approved or not. So what we're going to do here is we're simply going to go ahead and look at release 28. And what I've done by clicking on that link is it's brought me to basically a more detailed status of what's going on with my particular release. On this page, I can see exactly what build it was originated from. And if I wanted to, I can click on this build. Might as well.
One thing that I find quite interesting is this, once you have a build, the one that you're showing here, then that is the same code that gets deployed across the environment.
So important. That is such an important concept. I've met customers who every time they want to go to a different environment, recompile their code. That's a no-no, right? Because lots of things can happen, right? You never know what might be introduced. Someone might have checked in code. Maybe they went and did something to the code to when you rebuild it, it's really not the same zeros and ones that you just blessed in this other environment. The whole point of taking the same code is that we run an exhaustive series of tests against these exact bits, right? So I know that these zeros and ones are good, and those are the only zeros and ones I want to move forward. I do not want to recompile that. I even take this best practice with me when I start doing Docker deployments as well. I build my image once and I store it in, for example, Docker Hub. And it's that image that I'm moving to each individual containers. I don't rebuild my images as I move from container to container. I use configuration to be able to make them change and behave differently. So that's a very good point. This is the code that we're moving from one environment to the next. And as you can see here, our build has a lot of good information. You must have talked about this in your continuous integration talk about the test and the code coverage. But it's nice to see that we build that traceability into our product to where easily from my release, I can jump to the build that actually triggered it, and then I can find some more information about that build. Maybe as a QA lead, if a lot of these are failing or your code coverage is really low or dipped, maybe I don't have the confidence to move the code forward. So it's nice to have it at your fingertips.
So like you saw there were 37 tests that passed, so that was good, and those were all unit tests that we have in the Parts Unlimited Simple.
Correct.
You can create a lot more, of course, in there and make sure that you have a lot more code coverage, but that would give the approver or the QA guy a better overview of how your build has happened.
Absolutely, absolutely. So here, as we can see, we're going to be going through 3 different environments. One's called Dev, Staging, and Production. We're currently through Dev. We did that 2 hours ago, and now we're basically sitting here waiting on me to go back in and approve it. So it's pending right now. And we give you the duration of each one of these different stages of our deployment, and it also it's calculating the time it's taking me to go ahead and approve it as well, right? Because that's wasted time. And when we go back and we're trying to look at what our lead time is, on how long does it take for me to commit code before it ends up into an environment, we can go back and point the finger at Donovan. It's like, you were the approver and it took you like 3 days to approve that change. What were you doing? Why did it take so long? So that we can go back in and fix that problem as well.
And that goes back to that other practice we talked about measuring everything.
Everything.
This is one thing that you can measure, is how long is it taken for someone to approve
Exactly.
a stage.
Absolutely. Obviously, we'll give you some outputs for the deployment that we've already done successfully, and as you can see here, we're starting to aggregate some test results.
Right.
So not only can we run tests during our build, which you should, but you should also turn around and run more tests in your release, because the types of tests that you're able to run are different.
Yeah.
When you're just compiling the code and it hasn't been deployed yet, you can run unit tests. Run your code in isolation with no external dependencies and get some good idea that they work the way they're supposed to individually. Now that we've actually deployed the code, we can actually start doing a lot more exhaustive, what we call integration testing, making sure that when I manipulate the front end, that data makes it all the way to the database, and then I can retrieve that data back, that the tracer bullet, like I like to call it, is actually working. All of our entire pipeline is working. Not only can we do functional testing like Selenium or Coded UI, I can go back in, I can do manual and exploratory, but we can even run load test during these environments as well, so that we can use Azure for cloud-based load testing to go and make sure that not only does it function, but it performs the way we want it to perform as well, all throughout your pipeline. And we're going to go into details on exactly how we configure that stuff. And this is an extensible model too, so you can go back in and you can actually add your own sections to this as an external part, which I like to point out. Our build and our release system are very highly extendable. I've been working really hard on a Docker extension that has a lot of different Docker tasks that I'm going to be adding to the system that perform really well in the scenarios that I need it to be. And as you can see here, I'm being reminded again once more, hey Donovan, we're waiting on you, right? So we try to make sure that you don't have to go to a specific page to get that approval. I was also sent an email that says, hey Donovan, we're waiting on you again, right? So the system is very aware of we need you to come in here and take some action so that we can keep moving our pipeline across. So we're going to go ahead and leave that for now, and we're going to go look at what we call environments. Now, I'm really touchy on the term environment. I have a series on release management, and I've been harping on the product team, so I'll go ahead and get on my soapbox real quick. I wish we would call this something different, right? Because I don't think of them as environments. Right. I think of them as logical groupings of a series of tasks that I want to perform that I might want approvals before or after. That is it, right? Because if I literally wanted to perform these tasks on 10 different machines across all my environments, there's nothing technically stopping me from doing it in this environment. If I wanted to deploy, for example, just my web app in one of these environments, and then my database in another environment because I want my DBA to come in and do an approval before I push that change, there's no reason that I cannot split that across multiple of these logical environments.
So you could have, going from what you mentioned, you could have a dev web and a dev queue database, and they both look at the same source of that came off of the CI.
And also are targeting the same physical hardware, right? The same physical environment. Because when most of us think of an environment, in our head we imagine machines to which we're going to deploy our code on. And we have a set of machines for dev, and we have a set of machines for QA, and we have a set of machines for production, right? And when I think of this, a lot of our customers are saying, okay, whatever I want to do in dev, I have to do it all in this block. And that's not true. Not really, as you just described, right? We can name these whatever we want to name these. And it could be dev stage 1, dev stage 2, dev stage 3, whatever you want it to be called, right? So I just want to make sure that's clear. Please don't lock yourself into everything that I do has to be done in one environment at one time. This is completely flexible. You can do whatever you'd like to do in it as well. So actually I'm going to back out. Right now I'm looking at an existing release, so there's certain things that are going to be locked down and read-only. So what I'm going to do here is I'm going to back up, and I'm actually going to edit the definition, not the actual run itself. That'll give me a little bit more flexibility. For example, it'll allow me to change the name of this, should I choose to do that. And it also allows me to add more tasks. I think one of the greatest things about our system is that the task library that we have available to you is just fantastic. And I always get a kick out of bringing this up, because when I go to all, the majority of the stuff on here has nothing to do with Microsoft. Traditionally, you would not expect Microsoft to be helping you do Android native development or iOS development. We can also help you deploy those things with things that we have Ant and Maven. So this list is really, really long of information that you normally wouldn't associate with Microsoft, but it is a new Microsoft, right? We've been saying that a lot.
And you can create your own tasks as well, right?
Absolutely. I have created so many of these, and the more I create, the more I want to create, because it's so easy to do, and I get ideas of what I want the task to do for me, and they become building blocks for you to build whatever pipeline that you want. One thing I like to point out whenever I talk about these systems is this utility tab. The mantra is this. It's very simple. If you can show me a command line, I can do it from my build and my release system. Period. And when I say period, it's because if you come down here to the bottom, we have a shell task, which includes Linux and Macs as well. So it's not just Windows machines I'm talking about. It's not just PowerShell and a command or a batch file. It's also bash scripts and things like that that we can use to be able to deploy our applications to our targets. So I always preach any language, any platform. And any platform includes iOS, Android, it includes Windows Phone, whatever it is that you need to deploy to, because we have integration with the Hockey app and things like that as well. So we have you covered from a mobile DevOps perspective just as well. So big fan of our task library. I write lots of my own custom tasks. And another thing that's really cool about it, the reason that I write so many of them, is because our task library is open source. So every one of these is in GitHub, and you can go and see exactly how they wrote theirs so that you can then use it to write your own, which is how I learn most of this stuff. So it's pretty cool. Again, you can define environments. Many environments, when you define them, are going to be similar to the environment that came before it. And we try to make that very efficient by simply allowing you to clone an environment, making it really easy for you to duplicate an environment. And then you can come back in that environment and just simply twiddle the values here. Normally targeting a different environment, maybe changing an environment variable or something to that effect.
Yeah, that's how we created the staging and production ones. Is we first defined we created the dev one, and then I just cloned it. And in the staging, we just added load testing as well, but that's the only difference.
Right.
Everything else was similar, and of course the variables for each environment.
Correct. The things that I don't mind changing, whenever I'm thinking of a DevOps pipeline, the two items I don't mind changing are what I call scale and configuration. What I mean by that is that in dev, sometimes I will deploy all of my application to one physical server. The database, the middle tier, and the front end are all there because it's just for my convenience and my quick vetting. But when I go to QA, the scale is different because I have to say I have a dedicated database server, I have a dedicated middle tier server, and I have a dedicated front end or web server. So the scale has changed, but the tasks that I'm going to perform are the same. I'm going to deploy my database, I'm going to deploy my front end, I'm going to deploy my middle tier. In dev, I happen to be talking to the same machine, but in QA, I happen to be talking to individual machines. Now, upgrade that into production. Production, the scale could even be bigger. Databases are clustered. We have things that are clustered together for the middle tier. So what I'm doing, again, is exactly the same. I'm deploying my database, my middle tier, and my front end, but the scale in which I'm deploying it has changed. And obviously the configuration, right?
Yeah.
Where my database lives in dev is different than it is in QA than it is in prod. And the applications need to know that. So I will change my configuration, and I might change my scale, but I don't try to change a lot of what I'm doing in each of my environments.
So in the Parts Unlimited demo that we have been using throughout the episodes, you can see there we have an Azure resource group that we deploy with the details about it, and it's the same ARM template that we use across all three, just different parameters as far as scale and admin passwords and etc.
Correct. And also I see that you're using a PowerShell, kind of proving anything that you can do. I'm assuming you're doing this for your swapping of the
Side
tasks?
swap, yes.
Exactly.
I could have used your
absolutely.
your
You could
custom
have
task,
you could have written your own task, which is
Yeah.
what I did, to where I just simply put in the to and from slots, and it handles the rest for me because I'd written this PowerShell. And I knew I was going to need the PowerShell more than once. The only downside to doing a PowerShell is that the PowerShell has to be in your repo.
Yeah,
right, so that it can be accessible because here you have to give it the path to the repo. And I knew that this is reusable PowerShell, so I just wrapped it in my own task, added the task to my system, and now I have a task that does the swap for me. So it's really nice that there's no wrong answer, right? If this is more convenient, then the system is flexible enough to let you do that. Other things I like to point out when we're talking about environments are those approvers. So as you can see here, we have the checkbox for automated. That means we're telling the system it's safe for you to enter dev at any time that you have a new build, and it's safe for you to leave dev every time that you're ready to leave dev without any approvers. Now, if we were to go back and look at our staging one, it's going to be slightly different. I am the person that they've chosen to be the approver of entering this particular stage, and until I say it's okay, the code will sit there indefinitely waiting for me to approve it.
Yep.
Now, what's nice is what if I've gone on vacation? That would be bad. Right? So you're not going to get this thing approved until I come back from vacation. What you can do instead of putting an individual is actually you can put a group there.
Group of people.
Exactly.
Yeah.
And then anyone in that group has the authority to move your code further down the pipeline. So it doesn't have to be that one individual person, which is really nice as well. As you said, you can have it for entering and exiting the environment. And it can be any combination of individuals and or groups.
Right.
So if you were to put 4 groups, then 4 individuals, one person from each group would have to come in and give their thumbs up, and then the code would finally move along.
Cool.
Yeah, very powerful stuff. I actually quite like it. There's also the ability to configure variables, because there's some variables that are going to be different for dev than they are for QA than they are for production. As you can see here, clearly we have a lot of dev named resources and variables that we're going to be using. And if we were to switch over to QA, those same variables are going to be available to us, but obviously they're going to be in stage or the name of the task that we're moving forward to.
Yeah, and we also have the admin password for the database. So Parts Unlimited, it's, half of it is a web app that gets deployed to an Azure web app, and the other part is a SQL database.
Okay.
So we use the admin password from here that gets passed into the resource group step.
Perfect.
And then it creates a database with that password and then takes that and creates a connection string to the web app.
Great.
So just by setting it here, it actually goes out, creates the environment if it's not there already, and makes sure that the web app has a connection to the database and the app can start running.
Great. And I also like the fact that you can encrypt this data.
Yeah.
So a password's not something you'd want in plain text.
Exactly, yeah.
And a lot of people use the same password for several other databases. And what's really nice here as well is we actually have variables at 2 different levels.
Right.
One of them is down here at the environment level, but we also have configuration up here to where you can define a variable to which is going to be the same across all of your environments. So that you don't have to define it multiple times. So if any of those values were the same, you could actually elevate it to a higher level, set it once, then have it apply to all of them. Go ahead.
One that I almost used here was the website name.
Okay.
So, or if you want to give a part of the site name that goes in here, and then you can use that throughout the environments and just put the environment extension at the end.
Absolutely.
So stage or dev.
Yep. And another thing that's interesting here is that if you were to define a variable here, let's say, for example, your dev and QA admin passwords were the same, clearly your production is not. You could actually define your password here that would automatically apply to dev and QA, but then in the production, redefine it, and then whatever you do in that production environment will overwrite the value that we have here globally. So it gives you a way to have the same, exactly.
Cool.
Yep, so it's kind of nice to be able to do it both ways. And then finally, I'm sure you talked about, or correct me if I'm wrong, did you talk about the agents and how they work in your CI?
No.
So our agents are really interesting because the same agent works for continuous integration that works for release management. So they're the same agent that uses the same task library, so you don't have to learn something different. For those who have already seen the episode on continuous integration, you should look very familiar, everything that I'm showing you here, because they're built off the same architecture. And I think that, it's great because it's by design that once you've spent time with our build system, you're immediately comfortable with our release system. Yep. We add a few new concepts like approvers and environments, but other than that, all the concepts are the same. Now, when you have an agent actually has certain capabilities associated with it. And those capabilities allow you to determine what you can or cannot build on that particular agent. So for example here, if we were to go to hosted and click on capabilities, we'll be able to see all the different types of technologies which its item can build for us. These are called capabilities. And we're going to map these capabilities to the demands of our particular build or release. If you were to have your own here, and the reason that a lot of people do have their own build agents is because they need some technology that simply is not hosted on our hosted agent. You might need Wix for your installers, or you might need a newer version of Azure PowerShell that's not on a hosted agent. You can spin up your own private agent and then add whatever capabilities that you want to that particular agent, which is really powerful. I just started doing that with some of my my Linux. So, because I create several different pools, and I have a pool for all my Linux agents, right? And I install all the capabilities on there as well. So what we do is we take those capabilities, we map them against these demands, and that helps the system figure out which of those agents should I use that matches the demands that we have here.
And that must be pretty handy for a large team with multiple featured teams and different requirements for different build agents.
Absolutely.
So you can create different pools for the dependencies that each team needs for their build system and release system.
Yep.
And then just map it.
Yep, because you get to choose which pool of agents you want to pull from. So you have a couple options there. You can go ahead and say, I would like to group all of my Linux and Macs and PCs differently, or you can literally put them all in the exact same pool, and based on the capabilities and the demands, we'll know that, oh, this one requires that it run on a Linux machine, or this one requires it runs on a Mac, so that you don't have to have multiple pools, but you give you that flexibility to create them should you need them. Yeah, good point.
Cool.
Yep, and then what else do we have under here? Obviously we talked about cloning. You can save these as templates. So if this series of tasks are a series that you can envision having to use multiple times in several different pipelines, you don't have to rebuild it from hand by scratch every single time. And even when you add a new environment, we actually have templates that you can use to actually determine what type of environment do you need to create. One that does an Azure Cloud Service, one that's deploying an Azure web app, a website, or they're actually called web apps now.
Yeah.
We need to update that. Or do you just want to have an empty one that you can start from scratch and go ahead and build to your heart's content? So it's really nice stuff there as well. Now, another thing that's really important is once you build your environments, you have your approver set up, and you have all the tasks, what are we actually deploying? Where do we pick up the actual bits that we're going to actually deploy? And that's through what we call an artifact. An artifact is the output of a build that has everything bundled into it, like the web app, the test cases that I need, and any other artifacts that we need to be able to successfully deploy your application. What's really nice is that we don't just work with our build system. We also work with things like Jenkins. So for all of our customers that are watching who are already using Jenkins, you don't have to switch to our build system. You might want to evaluate it again, and you might want to switch to our build system. Our build system now is really, really good. But you can stay in Jenkins, and actually we can actually pick up that build from Jenkins and actually start deploying it down our release pipeline for you. If you're using TFS on-prem, we consider that basically team build external.
Right.
We can still go and grab those outputs for you and actually deploy them down the pipeline for you. And obviously if you're using VSTS for your build, you would just simply use build. And you can add as many artifacts as you like.
So that's the build that we covered in the continuous integration. So it basically whenever that build runs and creates an output and it's successful, then it shows up here for release management to deploy.
Absolutely. And what's really nice is that they talk to each other. We've already talked about configuration, so I'll skip over that and go to triggers. And this is where we've basically told release management, I would like you to watch that build over there. And every time that build finishes, I want you to start running whatever output it produced for us. And that's exactly what we're doing here. So they were doing true continuous deployment. So again, just imagine a developer checks in code, and moments later, that code is actually running on an environment. And that's what we're going to be able to enable for you here. We have a three-staged deployment here, dev, staging, and production. Not every build do you want to go to production every single time, especially when you're doing a lot of CI builds. If your CI builds are going through here, you might want them to stop in dev or maybe stop in staging. And then I individually cherry pick that's the one that I want to go to production based on its code coverage, based on our test results, based on its performance of our web performance testing. Of these 5, that's the one that I want. So you don't have to inundate production with all these builds if you don't want to. You can actually say, I want you to stop at staging with every deployment, and then I'm going to come back in and promote whichever one that I want to production. Which is what I do on one of my sites, because I use this stuff, right? And I have a production site that's every single time I check in code, it is deployed, but then I come in and decide, do I want to go ahead and swap that over into production or not? Finally, generals, not much on here today. It basically gives you a naming format for our releases. And then we basically support the same history that we supported in our build system and our release system as well. So again, everything that you learned in our build, the build episode, all of that is true in the release episode here that we're talking about today, but just the concept of environments and approvals. So let's go back real quick and take a look at the releases that we had. No, we don't need to keep any of those changes. This is another view of the same information, right? So this is a releases view of all the releases that we've done over the course of a period of time. Quick links to the build, and obviously that another reminder that this is all my fault. So let me go ahead and approve this and say looks good. And let's see what happens when I approve this. So when I go ahead and approve this, what should happen is the system should wake up and say, okay, it's time for me to start moving this. And if I were to go over to our log section here, you'll see that we have real-time logs for even your releases, so that you can see and monitor in real time exactly what's happening on those agents and where we are in your deployment. So if something's taking a really long time, You don't have to wonder if it's frozen or not. You can come in here and actually see the output in real time. You can go back anytime that you'd like to and obviously review the output of previous actions that have already been taken.
Right.
And we also give you two other things when you're looking at a review, the ability to look at work items. TFS has always been good at traceability, VSTS is as well. When you're working on code and you have the work item or the bug in front of you, you're able to actually commit it to a repository or source control and associate a work item to the code that you're checking in,
Yep.
so that in the future I can go back and say, Donovan, what files did you change to fix bug XYZ? We can actually go find bug XYZ, and it'll show me every time I checked in code, and I can go and look at every line of code that I changed. When you do that, it also flows all the way into our release pipeline, because I would be very curious on what bugs am I deploying right now. What features do we think are in this build that we're trying to deploy to production? And this screen will actually allow you to see all those bugs or features or change requests or whatever it is that you were working on that are actually getting deployed right now because of this particular release. And we do the same thing with commits as well.
Right.
So every check-in that's happened since the last time, and as you can see, we're basically releasing the same build over and over again here. And I can prove that because if we go back one more time to the beginning, you can look at these icons. This one was continuous deployed, right? There was a continuous deploy of this one. This one I'm deploying right now, which means there was no code changes. I'm just releasing the same code. So in theory, if I come here and go to commits, you can see that there was a check-in that actually triggered this release.
That's a,
through a
good,
build.
a very good developer, by the way.
Oh,
Yeah.
I heard great things about this guy. Great things about him. I don't know if they're all true or not, but I've heard a lot of great things. And again, echoing the whole traceability, right? Being able to effortlessly move from my release into the code that actually changed, that actually caused this particular release. So again, we're
pretty
working
cool, yeah.
really hard to make sure that there's just this one pane of glass. I mean, if you were to go back 2 years ago and do the same demo, I would have taken you inside of Visual Studio, I would have taken you to a web browser, I would have taken you into Microsoft Test Manager, I would have had to take you into release management, and now we give you all that information at your fingertips right through a web browser.
Cool.
Yeah.
And do you want to show the Azure portal where the deployments are?
Sure, we can go back in there. Actually, I think you're going to have to log in here because you're going to be using your Azure account to deploy to there, right?
Yes.
Yeah, so let's go ahead and swap sides real quick,
Okay.
and then we'll let
Cool.
you drive for that section.
We'll be right back. All right, so we swapped places now, and I just signed into my Azure subscription. So to remind you, with the definition here of the Parts Unlimited one, we have the 3 environments. And for dev, we have a resource group deployment that's deploying to a website called website name. So you can see there at the bottom. And that's just configured here as configurable variable that Donovan showed, called DevOps Fund Web and Dev. And also the resource group is called resource group. So that's another configuration variable here that we have. And we called it DevOps Fund Dev. So whenever we're deploying to the staging slot on the web app for that resource group. So if we go to DevOps Fund Dev here, we'll see everything that got deployed as part of the ARM template. That's a database server, and a website called DevOps Fund Dev Web Dev, and its staging slot. So whenever we deploy, it gets deployed to the staging slot, and I'll browse to that here. And that's just a Parts Unlimited solution that we've been playing with. And you can see here the discount is 30% on the homepage, because that was the change that I made that you approved.
Okay.
And
I should have verified that before you
Yeah.
approved it. 30% sounds like a lot.
yeah, too much discount. But if we go to production here, we'll have the same solution deployed in a completely different resource group. And of course, you can configure different scales like we mentioned, and etc. So once we go through staging, it goes through the testing and the cloud-based web performance testing, and then we do the site swap, and once that gets approved, it goes to production. So, So what we have in production here on the production website, if I browse to that, is the same website, but with it should still have the previous version of the discount.
Sure.
So it's not that big a discount. I think it's only 25%.
Okay.
So let that load while I show the release that we have. You can see it failed here, so there must have been some
Something
problem
wrong,
with the,
absolutely.
with
So
the
we got rejected.
rejected.
So, yeah, if we go ahead and look at the logs, go to the far right for me under logs. And what this is going to do is it's going to give us a detailed report of exactly what happened. And it looks like we had some issues with our test assemblies here.
So one test failed probably, and then it rejected that, and it's not going ahead with the deployment.
Right, and there's a couple of things that we can do there. You can actually say that if the test fails, I want you to abandon everything, which I obviously would do if there was a automatic like moving forward to back.
Yeah.
But you can also say, I don't want you to fail my release just because some tests fail. Right. You can also say, I want you to continue anyway. And I might do that if I have a approver on the outside who can go back and say, okay, is that just a flaky test that we need to go back and reevaluate? Was it an environment issue that caused that test to fail? So it's just kind of nice to have that flexibility again to be able to say, if any tests fail, I want you to fail my release. So because I have an automatic exit. Or I can say, regardless if they fail or not, I want you to continue because I have someone there that's going to take care of it for me.
So in the definition, that would be, say for example here, that would be continue on error. Is
exactly. That is correct. And that one would allow it to continue even if some of your tests were to fail as well. So it's up to you. Cool. So I just like the fact that it allows you to quickly find that. And another thing that you could do is if it was a flaky test, which obviously is a bad thing, we need to go fix that. You could easily restart that pipeline, right? You can go back to say, hey, okay, it failed going through stage. Let's just restart it and see if it was something flaky. And it'll attempt to go through that again, including requiring me to approve the restart of your pipeline.
Okay, so we could go into here and restart.
Yep. And what it'll do is it's going to immediately go back to the point to where Donovan has to approve it. See?
Okay.
So as you can see, the little icon shows up there.
Right.
And I think you're an admin, so you should be able to go ahead and...
we're still logged in as you.
Oh, you are? Oh, perfect.
So
So you can go ahead and try it again. You can just say try again.
Awesome code.
Yeah, so awesome that it failed the first time.
Yeah. Didn't even pass the test.
Exactly. Exactly.
So we'll kick that off again.
And we'll see how we get, if we make any progress.
But the main thing I wanted to show you is that because the way that we're doing this, we're looking after the environment, deploying into it, and running tests. In the end, we end up with 3 different environments here on Azure, defined as different resource groups, and then inside of each we have a staging slot, and that's something that you and I discussed quite a lot before, is that you deploy to the staging slot and then you do a little site swap so that there's no downtime on the deployment.
Absolutely. And I remember the first time that I got introduced to deployment slots, I was like, oh, this is going to be awesome. I'm simply going to have like 7 slots on my website, and I'm just going to swap my way into production. And if you think about that, the way that we actually do deployment, it's a very dangerous thing to consider, right? Because as this is a perfect example. It's almost like we planned this. Restarting a stage. Let's say, for example, that I just wanted to go and swap my way into production. So what we would have done is we would have simply swapped dev to QA or dev to stage. That would have been our action. Now, when we restart it, what would we actually be doing? We'd be taking what we really want and swapping it back out, which would not be what we were trying to do when we restart a stage. That's why what you do in a stage has to be identical. So what we did here is we copied the files that we wanted to the staging slot, which no one can see. And then we went and ran tests on it. And the beautiful thing is none of our end users are even aware that we're doing this. And none of them were impacted by the bad code because we never swapped it into the live slot that they were seeing. And what's also nice about that is if the test had passed, we would have swapped it. It would have been 0 downtime deployment. Because when you're copying, for example, an ASP.NET application, during the copy, we actually take the site down for a moment, right? It has this little catch-all HTML page that says the site's being updated. We'll be right back. But at that time, your customers are no longer able to use your site. And only in a demo does that happen very, very quickly. Real sites are relatively large, takes a while to copy, and at that period of time you're no longer making money, your customers are unhappy. But with the deployment slots, I can take as long as I need to deploy to that staging slot. And once it's done, at a push of a button, it swaps it into production with 0 downtime. And I love the way that we've added it to our pipelines here, because we're able to go back in, do some quick smoke tests and say, oh man, this has no reason to make its way into production. But you want to do the swap in every single slot, not just swap your way into production.
That's cool. Yeah, and also because we're running the load test on the staging slot, on the staging environment itself, completely separate from production, then we can load test it as much as we like.
That's
and
a great
we can
point.
Test out, scale out, and scale back in without annoying any customers.
Exactly. And then I think the point he's making there is that all slots of the same web app exist on the same physical hardware, which means You never want to actually do load testing on the staging slot of your actual production website, because you're loading that entire physical machine. So its network is going to be impacted, its memory is going to be impacted, even though you think you're on a different slot, because they share the same machine. So you would never want to run load test on a slot that's hosting your production website.
Yep.
Because it impacts everyone.
Yeah, so they, this production one depends on this app service plan that you can then define how big or small you want, and then the other two have their own service plan as well.
Perfect.
Yeah.
Yep. But they look identical, which is great.
Yeah.
So that if I need to restart it, I know that I'm going to get the same end result every time I restart my stage. And that was a lesson I learned the hard way. So I have this best practices deck that I'll do every once in a while, and the sad thing is that every slide is a reminder of something that I did wrong at one point.
Cool.
Great.
All right. Look like
We're getting a little further. Yeah, we're getting a little further.
The test passed.
So we might have a flaky test there, right?
Yeah.
That we have to go back and do some evaluation on and why
Double
it failed the
check
first
why,
time.
yeah.
Exactly, exactly.
That is running some Selenium tests.
Okay.
So it might have been something to do with the browser or the way that the test was written for that specific one.
Potentially,
So
potentially.
I'll look into it.
And you're using a hosted build agent, if I'm not
Yes.
mistaken. So you're
Yeah.
using the Phantom driver.
Yes.
Oh, okay.
Yeah.
Very cool. Very cool.
Yeah. And of course, if you want to run then Chrome and others, then you would go with your own.
Exactly. That's how I do all my demos. I want to run against actual Chrome
Yeah.
and against actual Firefox. So what I did is I stood up several of my own private agents, which you can do. It's very simple to stand up an agent. And then I run my agent in what we call interactive mode, which makes it able to interact with the desktop and launch browsers and things like that. And what's really neat is I actually don't have Chrome on all of my agents, but I added that as a capability.
Yeah.
And then I demand on whatever environment I need to that you have Chrome, because I know I'm going to run all my tests on Chrome. And then Chrome pops up, I execute my test, and then in the next environment I might use Firefox or some other browser. So if you need the browser to actually fire up, you cannot do that on our hosted builds, because our hosted build agents don't run in interactive.
It needs the admin rights and stuff like that.
It's basically it's running as a Windows service, and our Windows service can't interact with the desktop yet.
Cool.
Very cool.
All right. So I hope that gives you a really great overview of the release management capabilities that we have. And also, of course, at the beginning, we covered the concept of release management and continuous deployment, which is part of our whole DevOps fundamentals here. The last slide, as always, we have resources besides Donovan's blog post that we covered at the beginning. We have a few. The ones that I like to call out every time is the two at the bottom. So we have the DevOps Practice Hands-On with Parts Unlimited apps. So that's a whole bunch of different hands-on labs that you can follow at your own pace. And we also have a series that you and David Tessar recorded called Release Management.
We've been actually partnering up quite a bit. It was funny. I saw a tweet today that said we're like the lethal weapon of DevOps, right? The two of us together, and it's always a blast because he kind of represents the ops side of the world, and I've been a developer for 20 years, so I always come from it from a very developer-centric perspective. And when we come together, it's really like we keep each other honest on that. It's not weighted too heavily ops or too heavily dev, and it's really been a great experience working with him to get that full DevOps experience.
Cool. So check that out. It, of course, expands a lot more into different things about the release management that we just gave you an overview today. And I think that's it.
It's been a pleasure.
Right.
Thanks so much for having me.
Yeah, thanks, guys. See you.
Take care.
To all of the environments that you have, not just production or not just dev. So I put it in between development and testing and release itself. And as usual, we have this mapping of a DevOps frame. With most of the DevOps practices that we talked about here, we have the 100 level, and in this case, it would be continuous delivery, ensuring that your environments are can be reconfigured exactly how you want it across multiple different environments, and be able to deliver code that is good and tested to all of them at any time and multiple times per week. And then, of course, on the practice itself, this is the configuration management practice. And then finally, from there, you can map to different products from Microsoft or from others. And today, the ones that we're going to cover are PowerShell, DSC, Azure Automation, Chef, and Puppet. Yep. Cool. So to get into what configuration management means, we're basically going to give you the textbook definition of configuration management. So that's the process in which all of the artifacts, everything that's relevant to your project and the relationship between them are stored, retrieved, and uniquely identified and modified. So that means that a continuation or an extension of infrastructure as code is the next level where everything inside the infrastructure is also in a way that you can configure and see the changes between versions. And of course, a lot of this falls into saving that into some central code repository. But as long as you can define it as files, and you can see changes between one and the other and configure not just the infrastructure, but the projects, the processes and things that are in there, that is considered configuration management. The questions that you could ask yourself when you're talking about configuration management, for example, is can you exactly reproduce your environments from all the way from an operating system, the hardware behind it, the patch levels, the software stack that's on top of it, like .NET or the Java Frame runtime, and the apps that are deployed into it. So if you can reproduce that, you're probably getting quite a long way into it. Can you easily make incremental changes to any of these and deploy them to any environment? And then finally, can you trace the changes back to an individual person or an individual commit into your code, and where it was made and all of that. So those are some of the questions that you should ask yourself, and if you can, then you're probably doing pretty well in the configuration management area.
Good.
And we just have a little animation here to show you the deployments going into the environments and the configuration. Cool. So as with the other episodes, so this section here, it's pretty quick, and then we're going to jump straight into demos. Unless you want to talk a little bit more about the what you think configuration management is.
No, I'm all about the demo.
All right, great. So let's do it.
Okay. So in the demo, I'll be showing configuration management, but I also wanted to put it in the context of continuous deployment, which is a key practice inside of DevOps. With configuration management, we think in terms of configuring the infrastructure, as Thiago was just saying, but
I have a little animation here to show you the deployments going into the environments and the configuration. Cool. So as with the other episodes, so this section here, it's pretty quick, and then we're going to jump straight into demos. Unless you want to talk a little bit more about the what you think configuration management is.
No, I'm all about the demo.
All right, great. So let's do it.
Okay. So in the demo, I'll be showing configuration management, but I also wanted to put it in the context of continuous deployment, which is a key practice inside of DevOps. With configuration management, we think in terms of configuring the infrastructure, as Thiago was just saying, but also configuring the contents of the VMs in their various roles. So the ARM template in Azure speak these days, Azure Resource Manager, you can write a template, and that template describes the infrastructure, which is network, storage, compute, and all of the various details involved to build out an application, to build out a SQL cluster, to build out an Active Directory cluster, and so on and so forth. And then you can actually add configuration to the template in the form of VM extensions. That allows you to define the details of what goes into each VM. So it can either be on a VM by VM basis, or it can also be classes of VMs. So web tier, for example, each of the VMs in the web tier can be identically provisioned by the same configuration. So that's the top half of the slide. In the bottom,
is pretty important, because when we talked about continuous deployment in the other episode, we showed the demos that we showed were all based on your solution. So we had an Azure web app with a soft SQL database and continuously deploying into environments that same solution. But this goes a little bit further to include the actual infrastructure, what runs inside the infrastructure to support that application as well.
Yep. Yep. And so the bottom half of the slide, again, just to put it in context with continuous deployment, is you have your various cycles of development, and then you deploy through some sort of build and deployment tool, generate packages or whatever you need to deploy into your environment, and then those changes get picked up by the VMs.
Cool.
So this is the architecture of the demo that I'll be showing. I won't be showing actually the code and the build and deploy and package, but again, that's just to put it in context. What I will be showing is 3 VMs, one of which is being configured by DSC pull server in Azure Automation. Another is being, the configuration is being stored by a Puppet enterprise server, and the third is being configured by a Chef server.
Cool.
So now I'm going to exit from the PowerPoint and flip over to the actual demo. The first thing I want to show in the demo is the various management servers and the list of nodes currently under management inside those servers. So in the Azure portal, I go to my automation account, and you can see here it says DSC nodes, and currently there's 0 in the list of nodes. And there's a reason for that. I'm going to build that node during the demo. The next one I want to show you is Puppet Enterprise Server. I'm just going to refresh this just to make sure my credentials are still current. And you can see here in the list that Go Live Pup VM is under management. It's got a little green check mark. It says it was unchanged 9 minutes ago. That means that that VM is actually checking in periodically and reporting back its current state to the Puppet Enterprise Server. And we can see that that's in a good state. Next one I'm going to look at is Chef. Under Chef management, I have one here called Go Live Chef VM. And it also has reported in recently. Let me go ahead and refresh this page just to be sure.
It is interesting how the VMs themselves are the ones that report into the server side.
Yeah, the configuration is stored on server side, and the VMs check in periodically to see if there's any changes to the configuration that's been set up for them.
Yeah.
If there's been no change in the configuration, then they check their existing configuration and see, are there any differences? Have I drifted? And if so, it'll try to bring it back. If there are changes at the server side, then it says, oh, okay, well, I need to add this new application, I need to add this new firewall rule, whatever it might be, and it'll come into sync. Cool. So as you can see, the configuration is here, and that's already in the list. So great. So I've got 3 VMs. I've got, well, the one for DSC management doesn't exist yet. The one for Puppet you saw just a second ago, and the one for Chef is on the screen. So let me go ahead and kick off the template, the ARM template, that will build that DSC server. Okay, so I'm going to create the resource group, and then, let's see, go ahead and run the template.
Cool.
And while
you'll see this is very similar to the one that we ran in the infrastructure as code, but this template goes a little bit further, right?
It does, a little bit further.
Yeah.
Not that I actually saw what you did earlier. No. But as you can see, there's resources in the template, storage, public IP addresses, virtual networks, and so on and so forth. But what I think Tiago is referring to is down here way at the bottom after the VM is actually a specification for a VM extension. And that VM extension is what is going to load up PowerShell DSC.
Right.
It will load up the Windows Management Framework version 5 production preview at this point in time. It's going to reboot the computer, and then it's going to pre-configure the environment based on these criteria. There's a registration key for my Azure Automation account.
Right.
There's a URL to my Azure Automation account so it can sign in and interact with the environment. And then there's a few details about how frequently it should check in, what its configuration name is, and so on and so forth.
Cool.
So all of this configuration is being baked into that VM as it's being created. And then as soon as that VM comes up and that extension is installed and working, it's going to check into the DSC pull server at Azure Automation find out what its configuration is, pull that configuration down, and then set itself up accordingly.
That's really cool. Yeah.
So while we're waiting on that, and we can see here that
The progress.
it's working, we can go back to the Azure portal and take a look at its progress. So while we're waiting on the DSC configured machine to come up, I wanted to show you some of the details of the configurations that are going into these machines. I'll start with the one that's going into the DSC managed machine. And so there's a list of DSC configurations here. Webhead config is the one that I'm using, and I can look at the view configuration source. And under configuration source, you can see there's a PS1 file that's been ingested into the Azure Automation DSC pull server and compiled. The source says that for this type of node, I'm going to load Chocolatey installer. I'll get around to Chocolatey here in just a few minutes. And then I'm going to load a Windows feature. I want to load the web server feature, and I want to load a few other Windows features in support of that web server capability. And then I'm going to go ahead and create a few firewall rules. And then I'm going to use that Chocolatey package installer that I referenced before to go ahead and install my little application, which is a trivial little web API application.
Right.
So back to Chocolatey real quick. I'm using Chocolatey in all three environments. Chocolatey is a package manager for the Windows environment. If you're familiar with Linux environments, you may be familiar with applications like apt-get or yum, which can allow you to say, sudo apt-get nginx or sudo apt-get, MySQL, and so on and so forth, and it'll download the packages and dependencies and install that information, that software onto the computer. And you can do exactly the same thing on a Windows computer with Chocolatey. You can actually say Chocolatey install Notepad++, and it'll install Notepad++ onto your computer. So the next configuration I wanted to show you is the one for Puppet, and for that I actually need to use an SSH shell that I've got set up talking to the Puppet server, and that configuration is in a file in the file system. Here's the name of the Puppet node that I'm configuring, and you can see here again I'm including Chocolatey and I'm including firewall. So these are basically modules that can be included into my configuration. Think of them as libraries with resource provider capabilities. And so then I define a firewall rule, I define my Windows IIS capabilities and all the various Windows features necessary for that to work correctly for a web API application. And then at the bottom you can see again where I have asked for my little trivial web API application to be pulled over from myget.org, which is the place that I'm using for my package repository.
Right.
So if we kind of shrink this just a little bit and move it over here to the side, you can see there's not a lot of difference between these two configurations. These configurations are designed to be both descriptive but also terse. So it's very easy for sysop or for a DevOps guy to just very quickly, this is what I want, make it so.
Right.
So the third one I'd like to show you is go ahead and just take a look at Chef Manage. You can take a look down here at the bottom at the configuration of this VM, Go Live Chef VM. It says that my run list is my web API Choco, which is my web API application using Chocolatey to do the package management. Right. And so to find the details of my web Choco, I run into the policy section. And it says there's no items, but I don't believe it. I'm going to refresh. There we go. So there's my web API Choco and the content for that. Let's make this a little bigger. Under recipes, there's default, and there it is. You can see again, I'm including Chocolatey, I'm including firewall, I define IIS, and I define a few firewall rules. And finally, I say to Chocolatey, please install Go Live Web API from my myget.org repository.
Cool. And so that package then installs your API, the web API that you created onto
Yeah, exactly. So I built the web API based on the Visual Studio template.
Yeah.
And that was one project inside my solution, my Visual Studio solution. And then I added another project to the solution, which is a Wix solution for building a package.
Yeah.
And so I configured Wix to go ahead and package up the assets for the Web API app and create an MSI.
Right.
All of this runs inside of VSTS. I can literally make a tweak to the code in my Web API solution project, and then test it, check it in, and then if I've got the little checkbox that says build on check-in, it'll build automatically.
Yep.
It'll go through all the machinations necessary to create the MSI, and then it actually stores the new version of the MSI in myget.org for me.
Right.
It updates my new spec. Everything's all automated.
Cool. So that's also take advantage of what we showed in the continuous integration episode here is you're using it for whenever you update your web API to package it up and push the package up to myget.
Right.
Yeah.
Yep.
Cool.
Exactly. So let's take a look and see if we have finished deploying that DSC computer.
And from an infrastructure perspective, you have one VM. We have one VM for the Puppet Master. The Chef is hosted. The Chef hosted. DSC is this PowerShell automation as a service on Azure.
Yep.
And all those are just the managers of the configuration that you want to do.
Exactly.
And each one of those you have created a virtual machine on Azure for each one of them to manage. And to report back into those.
And I'll show the diagram again here in a few minutes, just so people can get oriented again as to what we've been talking about. So we've waited a few minutes for the DSC managed computer to become ready, and so let's go take a look. You can see now from before it said DSC nodes was 0. Now there's 1 because the VM has automatically registered itself. We also waited for it to go ahead and finish its compliancy. And so if we check in a little bit on the details, we can see that it's in a compliant state. And there's a nice report of all the different steps it took. And if you looked at it very closely, you would see that it installed IIS and all the features that we asked for. It installed Chocolatey and a few firewall rules, and then it installed my Web API application.
So it reports as compliant once it's finished installing everything that you asked.
And then every 30 minutes, actually it's every 15 minutes, it checks back to see if the configuration has changed.
All right.
And even if the configuration hasn't changed, it's going to check to see, am I still in compliance with the configuration that's currently in place.
Right.
So great. So the next thing to do is just to verify that all this stuff worked. And to do that, I have a browser here. I'm just going to copy these URLs and delete the page and paste it back in. So here's the Chef one, and it popped up. And here's the Puppet. Let's grab his pointer and create a new page, paste it in. And the Puppet's working, and then the DSC, copy that. Put a new tab, take a look, and there it is.
Cool. So that's the same web API that you had in the package.
Same web API that I installed in the package, and I know because out here at the end I actually added a feature to the application. Here it's reporting the version number 1.19.
Right.
Yeah.
Cool.
So.
All right. So let's go back to the slide and just to show your
you bet.
architecture again.
Mm-hmm. Let's see.
That's fine.
Okay, done it. All right. Fantastic. So just a quick review. I previously built and deployed the package, and so it's in place and ready to go.
So that is on.
It's on myget.org.
Myget.org. Yeah.
Right. I had created and started up my Puppet server. The Chef server is the hosted Chef server that they maintain, and I loaded the configuration there previously. And then the configuration for the DSC managed server was loaded in previously as well, and creating that VM, loading the DSC VM extension, getting that DSC extension running, then the VM checked in, pulled down that configuration, said, oh, okay, I need to install IIS, I need to install some firewall rules, I need to install Chocolatey, and then Chocolatey was asked to go ahead and install the web API. And so that's
Cool.
That's it.
And
Fantastic.
that's the usual slide that we talk about the resources that we have. Make sure you check out the hands-on labs. We don't have a hands-on lab that is directly related to configuration management. We have one on infrastructure as code and a few of the others, so do check them out. And we have a few other resources here, like the DevOps Dimension show, where we interview people from both inside Microsoft and from companies that we know that are implementing good DevOps practices, and we talk to them about what they learned and the best practices that they got from there. So with that, thank you again, Greg, and thanks everyone. We'll see you in the next episode.
AR.
Great. Not DTSAR.
I don't know who's made that mistake. Anyway. All right, so DevOps. Again, we kind of beating the drum here in case you're just watching this standalone. But DevOps, you're going to have your developers, operations, and other people who are involved in delivering value throughout the entire chain, all the way through the entire application life cycles, which is what we are showing you here. Now, for monitoring, not surprisingly, typically it's going to be involved in the monitoring and learn phase of the application development lifecycle. That being said, I think it's also important to point out that some of these concepts, such as application performance monitoring, can absolutely be applied before you hit production, and in some cases that is recommended, right? So ideally, if you find performance problems before you go to production, that would be a good thing.
Yeah.
So there we go. Okay, so how does application performance monitoring fit, and what does that mean? So application performance monitoring and availability monitoring can be included as what we're calling DevOps practices. And that helps to bridge the gap in terms of how you can think about which type of technologies are involved for any particular thing. So there's a lot of different ways and a lot of different products that can enable availability and application performance monitoring. For what we're going to talk about today in Microsoft solutions, the two major ones that we have are Application Insights, which is what we're going to cover today, and then System Center also has an application performance and availability monitoring subsystem inside of itself, which we're not going to cover, although the concepts are exactly the same.
Yeah, and there's one DevOps idea or concept that people talk about a lot, is to measure everything, and also have the teams that are involved with a specific deployment or a specific feature that you're implementing, they're responsible also for what's running in production. So that makes people very interested in knowing specific details of who's using their solution in production, how it's behaving, and etc. Because ultimately you're going to be responsible. You're going to be in the team that's responsible for any problems that happen in production, or if you got to a phase where you want to test different options of deployments, then you would want to know how one compares to the other, and we're going to cover that in the advanced monitoring, advanced topics episode. And this definitely Application Insight, System Center, and the overall application performance monitoring falls into that.
Okay, so what is application performance monitoring? Well, at a high level, application performance monitoring typically is going to involve some form of agent running on your application in production, which is what you saw the little cog there running. That then is going to in turn submit information up to some form of monitoring service. That little agent is sending data, sending information about all kinds of various things about that application running in that environment. And you can set up alerts, notifications, all kinds of other things with that monitoring service to let you know, hey, there's a problem, or oh, performance is slow, something's going wrong, and then give you that rich kind of data that you need to help try and resolve issues. So this is naturally going to give you a lot better idea of detecting and remediating things. I think this is a really good one on the people side to enable and help developers and operations work together. Because quite often, you find organizations that ops just handles it, right? If you're in a traditional non-DevOps org, dev kind of codes, throws it over the wall, ops does all this stuff, and then ops has to really do the brunt of the work and figure out, is it code, is it infrastructure? What's the problem? Well, APM will really help you to determine that much faster, right? Because you can tell and say, well, is there a performance problem, and analyze the infrastructure, or possibly even get down to a code level line of where there's a delay or an issue, and that way you can more quickly remediate issues that you have inside of your environments. It also, likewise, it doesn't have to be only for detection of problems, right? You could have instances where maybe you just want things to be a better performance, or it might be something that you're over or underutilizing some of the underlying infrastructure resources that you have. So for instance, you've got way too big of an instance compute size and you're overpaying. So it can help you to really optimize those resources as well as another byproduct or benefit of implementing APM. And so naturally, in terms of ways that you could help to measure if you went ahead and implemented this, if you were detecting or measuring, I should say, mean time to detection and mean time to repair, and availability all kind of tie in the same concepts. Those are things that you should notice an improvement in if you implement the application performance monitoring.
Cool. Yeah, and when we talk to customers that have implemented this, one other benefit that they see is quite often they find out that there's a problem before their customers do. And they are able, because they have also a process to deploy updates or changes to production quickly, they can also fix that before any customers is actually heavily impacted, or at least they reduce the amount of customers that are impacted by it.
Absolutely. And again, a second reminder, I'd said this before, but APM I think is a good one that you could use. A great combination is if you use this in conjunction with a automated load performance test in, let's say, a staging environment. And then you have the application performance monitoring agent on there, run the load against it in stage, so you can find those performance problems before you run into production. So it was kind of a good combination one that's good to think about. Availability monitoring. Now, this is very much not a new concept. Yeah. I think everybody's been doing availability monitoring for ages. And it is kind of a bare essential kind of minimum bar for, I'd say, any production application. So we'll kind of talk about the basic here, and of course you're going to have some form of monitoring service. That monitoring service, usually from the outside, you can do some internal monitoring, but somehow it's sitting there checking functionality of the application. Is it up? Is it available? Is it running? And can give you some alerts back to the service and then give you some notifications. That general thing is going to, if you move forward, it's going to give you some alerts, some data, going to give you some basic information, to get your issues resolved faster. The thing that I will say is that there is what I would call really basic availability monitoring. Basic availability monitoring I'll label as something as simple as a ping test or a HTTP 200. 200, okay, right, we're good. But the reality is that things are a lot more complex than that, right? And if you do just the basic availability, there's nothing wrong with that. I think it's okay. But especially in a DevOps world, I think you really need to evolve and get more advanced. And so there's what I'll call advanced availability monitoring. And if you're really into what I'm saying as advanced availability monitoring, you're doing things like Tiago's going to show you here, which is that you're doing more advanced things like functional tests for your availability monitoring that resemble a specific set of tasks or things that you want to make sure are working.
Yep.
So for instance, I want to ensure that users can register. And so I'm going to have I'll call it advanced availability monitoring test to ensure that that user can log in. And I'm going to run that every 5 minutes, and I'm going to see the performance around the world, perhaps, with that particular test. So that's advanced availability monitoring, and I think that there is a good blend here. We're talking fundamentals, so we don't have time to go extremely in depth here, but generally speaking, having an alignment behind all the way from what is it that we're developing that has new feature functionality that we care about, having that kind of functional tests run all the way through your let's say, deployment pipeline, all the way up into production where you have perhaps a subset of the Uber set of things that you want to work that you're testing on a regular basis in production. That's advanced availability monitoring, and I would say that's really where more of the DevOps type of practice comes into play, because if it's just HTTP 200, I don't even know if I'd really call that a DevOps practice. I'd almost just call that availability monitoring that's been around forever, right?
Yeah.
So, all right.
Cool.
Yeah. Okay. One thing that, so we have at Microsoft, the product that lights up both of these DevOps practices as well as some others is Application Insights. And I think it's important that you understand how this kind of breaks down, because the one product actually enables multiple DevOps practices. So first up, the thing that you can do with no code modification to your application is outside-in monitoring. And this can be basic availability monitoring or advanced availability monitoring, but it requires zero modification to the application code that you have. At least the way it is today, it does require that it's outside in, meaning from the internet, your application has to be accessible for this to function. And so that's kind of the minimum bar. After that, one of the next things you can do with App Insights is with a simple JavaScript, you can, which is point 2 here, you can just embed that JavaScript. That JavaScript is then going to give you basic kind of information about people that are visiting your, let's say, web application, right? Such as what browser are you using, what operating system are you using, where did you come from, that basic kind of information. So that's kind of the next level, where obviously you would have code modification would be kind of a simple JavaScript that you would put somewhere that is run every single time for across all the app that you want to track. Then you go to, let's say, the next level of depth, and these don't necessarily have to be done in this order, but just to give you an idea. So number 3, this would be developer traces events. And we are going to cover this in more depth in the advanced DevOps module. This is what I would call user telemetry. And you could try and say that 2 is kind of part of that, and I guess to a certain extent it is. But I would say true user telemetry, you're doing some custom detection of what are the users doing. And for that, you're going to have to enable the App Insights SDK and attach that into your product. That's going to enable you to have really full custom functionality in determining what you want to do. And we're not going to cover that in the scope of this module, but the one later we'll get into that more. For 4 and 5, App Insights also enables application behavior and infrastructure performance. So to enable 4 and 5, you do have to enable the agent on the virtual machine. So 4 and 5 really are what I would call the application, or what light up the application performance monitoring. And for that, you do have to have at least the App Insights SDK installed and the agent installed. So it does require the combination of both, but that's going to give you the richest, deep information that really now you're lighting up application performance monitoring. And Tiago is going to show you more a little bit about what that looks like. So App Insights does a lot of stuff, as you can see, and different levels or levers that you can pull to enable different things within App Insights.
Yep.
Okay.
Cool. All right, so it's demo time. Let's have a look at some of the stuff that David talked to us about. So here, we're going to go over to my portal. I'll reload that. And while I sign in here, I'm going to go into Visual Studio and show you where you would add the SDK for it. Or at least the first step, you can get a specific amount of JavaScript from your Application Insights bucket on Azure and add it to every page of your website. So that's the basic one. So if I have a look at the website code here, and if I check out the views, and there's the layout.cshtml. This is popular on this type of ASP.NET application because it's inherited by every other page, so you only have to edit once. And I just added that piece of JavaScript there. So it goes out to application insights and registers itself against a specific application insight bucket that you have. And you can see here I'm getting the instrumentation key from a configuration file. So instead of having it hard-coded on the site, it's actually picking it up from an environment variable that I'm setting as well. So on the Azure side, if we have a look here on our production app solution for Parts Unlimited, I have that application insights account here. And in here, we have quick starts, for example, if you want to learn how to get started. And the JavaScript code that you would add is right there. So this is what I copied and pasted to that layout.cs HTML. And you can see here it has my instrumentation key. The only difference is that I changed that to pick it up from an environment variable. The reason why is because for my website, when I look at the website that relates to this, it is looking for that in the configuration of the web app itself, and then it passes it into application insights. So that's the basic one, and that gives you quite a few things like page view, the duration of the page view, where the users are coming from, which country, for example, and that type of information. And which pages took the longest, the dependencies that it has, and etc. So that's the first one. The next one is the SDK, so the user custom telemetry. So if you go from we have for Java as well and other languages, but from here from ASP.NET, you can go and right-click, and there, because I've already configured it, it's already telling me to configure it again. But you can also, and it's showing that I already have it, so it's pretty much configured. But you would have a add application insights option here, and then you would select which application insights you would use. And that basically adds a few references like Microsoft.application insights, so a few NuGet packages that wires up into ASP.NET to get more specific details on which methods are being called, which ones are taking the longest, user sessions, and etc. from the solution.
It's going to give you the custom telemetry, and it's going to give you it's kind of the core foundation for a lot of the plumbing for App Insights.
Yeah.
But yeah, that you could stop there and still get a lot of rich data.
Yeah. So for example, here I saved a favorite search, and this is a custom event that I created. For example, it doesn't seem to have found any, but if it did, then we would see the DO20 entries. So I'll just change the time range here for the last 48 hours, and now we should get a couple of them. So you can see here, these are custom events. So I basically just use this to do a custom user event to say, carousel test the DO20, and that says someone clicked on the button that had a 20% off deal.
Yeah,
So
and we'll
that's
cover that. We'll cover that more in the advanced
Yes,
DevOps practice
absolutely.
module. But that just gives you a rough feel.
Yep. And finally, if you want to add the agent on a virtual machine, if you're running your site on premises or in the cloud or somewhere else, and you want to add it, there's an agent that you download and install, and that starts monitoring IIS and the server itself and gives you a lot more information here against application insights. For a web app, if you have a web app, so I have this one here, DevOps Fund Web. It's just an extension, a web app extension. So if I go to Tools, Extensions at the end here, you can see that I've already added, once it loads, it'll show that I've added the Application Insights extension. And that basically just adds the agent behind the scenes to the machine that's hosting your web app. And of course, you can add a few more extensions as well.
Yeah, so that the combination of the SDK and the agent is really what's going to light up application performance monitoring and give you all of the rich data on what are your dependencies, what are all the calls, what are happening, what are the errors. If you want to do dump of event logs or traces or things of that nature when certain things happen, that's where you're going to get the full capabilities of App Insights.
We have two more things to show. So one is we can have a look if we go to the original monitoring here, and let me go to the main one here. And if we have a look at the the response time, for example, or the server requests, we'll see that it will list the operations that are taking the longest once it loads, and we'll see that there's quite a few interesting ones here that you can monitor. Also on the server response, it also gives you a lot more detail. So definitely, there is not just the main page, but you can see all the way drilled down into specific calls or specific operations. And you see that there's one specific one, SignalR. I know that it keeps the connection open, so that's why it's going for 9 minutes or 6 minutes. But this one is a bit interesting. It's the get home recommendations, and it's taking 15 seconds to load. So that's a lot more than I expected. If you look at all the other ones, they're all milliseconds. So that gives me an idea to go into the code and have a look at that specific method.
So if we clicked on that home recommendations, maybe we would get just some ideas of the trace or other things that are happening in there. But at a bare minimum, you're seeing that, hey, this page is loading very slowly, and we probably need to investigate because there's 232 people who, on average, are seeing this kind of delay.
Yeah, and on average, it's taking 15 seconds, so that's definitely worth looking into. And these are all the specific occurrences of it, different times. Some of them take a little bit longer, some less, but it's still in a matter of seconds instead of milliseconds, which is not what I expected from that method.
Well, and this is another case, too, where if you're doing just basic availability monitoring, yep, I got a response code of 200.
Yeah.
but it's taken 15 seconds to get something done. So it's really a failure without having APM enabled, right?
Yeah, so what I can do is then go into the code and have a look at that specific method. It's in the home controller. And if we have a look here at recommendations, it is doing a while count and then go into the database to get a specific list. And if we go to the definition of this, it's 1,000 instead of 10 or 1. So that's the reason why it's just looping through, making calls to the database, and then delaying the page from showing. Mm-hmm. So that's one way that you can go all the way from application insights through to the code and figure out why it's failing.
Yeah, and depending on when you're watching this, or what your application's looking like, you may at some point be able to get richer data, even down to the code level line of information stating that this is the line of code that was causing a potential problem. It kind of depends on your exact scenario and where we're at with the product. But yeah, that's also a possibility.
Cool. And then the final one that I wanted to show is availability monitoring itself. So if we go back to the home of my application insights here, at the top we have availability. And this here, what I've created is true web tests. And you can create as many web tests as you like. You can add a web test here. And you see that there's a couple of types. One is just URL ping. So you can just give it defaults to the URL of the web app that this is related to, but you can change it to any. And you give it a name, and it's just going to ping that URL every 5 minutes. You can configure the frequency. And you can also choose different test locations. So we have a whole lot of different locations throughout the globe that you can choose from to see. So if you have a lot of customers in Brazil and you want to make sure that there's no apparent delay time for them to access your site, you can enable this and then tell it to alert you if a number of locations have failed that in that past 5 minutes. Mm-hmm. So you could have different locations throughout the world pinging your site, and if any number of them, like more than 3, report that they took more than a specific amount of time to respond, then it's going to send you an email and let you know that your site is not behaving like you wanted it to. Mm-hmm. So that's the one type. It's the ping one. And it also supports a little bit more advanced type of testing, it's called multi-step test here on the Application Insights. And what that relates to on Visual Studio is a web test. So here I've created a Parts Unlimited UI tests. I have a Selenium test that I run through the release management part of our solution, but also I created a couple of web tests. So here you can just, when you go and add a web performance test, it's basically going to open up the browser and let me start browsing to it, and then it's going to start recording everything that I do. You see it's already selecting everything that we're loading. So that's what you do. You can do that and it'll create the test for you. But just to show you, we have this web test general that basically browses through, cancel this out. It browses through the site and adds a couple of items to the cart. On the Azure side, so if you're looking at the results from this, we can have a look at that specific web test, the general one. Just to show you, you would select a file, and the file that you select is that web test that I just showed, just to complete this part.
So I think I want to pause for a second here because I think this is really important. I mean, I know a number of you likely out there have some department that's doing probably some kind of functional test. I'll just call it a functional test for ease of simplicity. But what Thiago just showed you is really likely, I mean, well, it is a functional test if you have a public-facing website, right? And
all right, welcome to another episode of DevOps Fundamentals. In this episode, we're going to talk about advanced DevOps practices. So, as usual, I'm Thiago Almeida at NZThiago on Twitter, and this is David.
David, Senior Technical Evangelist at DTZAR.
Cool. All right, so let's just jump into some of the topics that we found, or practices that we found, that are a little bit more advanced once you've mastered the main ones that we've been talking about.
You don't necessarily have to master them all, but typically we find that these ones are folks who have kind of gotten some of the other ones in place before they want to come here. Some of them there is some dependencies. So for instance, this one is one in particular where you probably are going to have a number of the ones in place. If not, I would say it's almost a requirement. Automated recovery. The first option, what we're talking about here, is called what we're saying rollback within the automated recovery bubble here. And so what happens there is, let's say you update the 2.0 version of the code and you push that out into production, and their 2.0 version of code breaks something. In a rollback scenario, what you would do is you would have, knowing that 1.0 is good, you would detect that problem and then push the 1.0 version of the build, let's say, out back into production to try and reduce your outage, or, your downtime, and help with your MTTR metric, right? Mean time to repair or recover. And this, like I said, you likely, could you do this if you had 0 of the other practices? Sure. But likely you're going to have things like continuous deployment enabled, you're going to probably have release management enabled, and the combination of those things, along with automated testing and APM and other things, are going to help you detect those things faster. Even testing in production, which we'll talk about in a little bit, can be used in conjunction with this to make this practice easier to implement. But the concept is, pretty straightforward, I think, for most folks to understand, is that, roll back to known good state to minimize the impact to your users that are out there. Roll forward, and we notice, some folks, especially if you've got a really advanced practice, most folks, I would say, do the roll forward option. Because if you've got, let's say, for instance, a true continuous delivery pipeline in place, you've got a lot of testing, you've got a lot of rich data. Let's say you have application performance monitoring enabled. The code line level change. You may have even found the problem before you get to production. So you, quote unquote, roll forward with that change and push that into production. And instead of going to 1.0, you just, let's do 2.1
with the
fix installed, and everybody's now on 2.1 with the fix.
Yeah.
There's a good kind of saying from Jez Humble that came up recently that is saying that, your hotfix or change management for emergency releases or whatever should be likely the bar that you should shoot for normal releases into production.
Yeah.
And in that case, you would probably just roll forward and push it up. Yeah.
Yeah, especially when you have database changes and a few other parts of your application. Usually it's easier to roll forward than try to reverse back to a previous state.
Yeah.
Yeah.
Yeah. As soon as you get state in there, it gets messy, right? With rollbacks. Yeah. Okay. Automated environment deprovisioning. This is one that I wouldn't necessarily say has to be in the advanced bucket or that you have to enable that has a ton of pre-dependencies. Perhaps some dependencies that might be there's infrastructure as code. Same thing with automated environment provisioning. And this is the basic concept that you've got a bunch of environments that are spun up. Usually it comes after the kind of self-service provisioning and infrastructure as code. But with great responsibility, or great power comes great responsibility, right? Yeah. And so if you've got, let's just say, this amazing infrastructure as code template, and developers are, firing away and just pushing all kinds of things up there, there's a cost, right, associated with that. And so as a responsible ops person, this would probably be one where you would likely be more heavily involved. And it would be things like, how can I automatically delete or get rid of resources that are no longer being used? And this is, in terms of the dev side, I'd say this is really a partnership that, is there where traditionally if you're the ops person or the company that says to the developer, it's going to take months or weeks to get your thing there, right? You have to change that paradigm and probably first get to self-service provisioning and infrastructure as code. Once you're kind of there, though, there's now an acceptance of, okay, you need to delete this, right? And you probably have got a workflow of how things are there, and you may have, there's the numerous ways, and we'll, for us anyway, since we're not going to demo this, you would use the Azure Automation service to, let's say, deprovision resource groups or specific things on a whatever basis as it relates to your provisioning process or how developers are using these environments that they have. We also have something related called DevTest Labs. DevTest Labs also has policies and things to help you shut down VMs or clean VMs up to help with, having an efficient use of the resources that you have out there.
Yeah, and especially nowadays with the public cloud providers, that you can get charged by the amount of VMs that you have running or amount of infrastructure that you have with them. It makes sense to deprovision the infrastructure that you're not using, and that's the measure there, lower TCO that this practice will give you.
Yeah, I mean it's a different mindset, right? As soon as you go to cloud, the VMs are by the minute.
Yeah.
So especially if you've got a gigantic VM that's up there, 1 minute could save you hundreds of dollars, or a couple minutes, you're talking a good chunk of money, right?
So it makes sense for the ops person to know what the dev team have deployed to the environment, and for the dev team to know where their stuff is running. And if you're monitoring everything, you will be able to make a sensible decision of how to automate the deprovisioning of environments that you don't need anymore.
Yeah. Mm-hmm.
All right. Next one. Or a group of them.
Yeah, this is a group of one, which we're going to get deeper into these three with the subsequent slides here. But at a high level, there's a concept called hypothesis-driven development. And this is definitely in the advanced bucket because once you have a lot of things fundamental of these DevOps practices enabled, a lot of things start to change. And it comes back to the concept of I'm spending this money, time, and effort for my developers to go and produce something, which I think the users are going to have value. Now, if you're like a lot of organizations, you may have, even if you're doing Agile, you may have the business have some good ideas. You may have done some user surveys and said the users really want this feature, X, Y, Z. And you go develop it and you're happy, and let's say you even get into production. Where I think a lot of people stop at is that's kind of it. They may follow up with a survey later or something like that they go talk to their users. But in a true hypothesis-driven development, I almost say culture, the mindset is have a minimum viable product or an MVP that you can push to users and know, one, are they using it? Are they successful? All of these types of concepts, right? And that not only goes for the features of the usage, but it also goes for the architecture, right? I have this highly available infrastructure. Is that working? Is that useful? Is that completing what I think is going to be useful, right? So it's a big mindset shift, and within that bucket you have what's the first one there on the list is testing in production. Testing in production says I'm going to send a percentage of my traffic to my production users, and that is going to give you, right, that data, like real live data to that. Let's, in this example, it's 90-10. Could be whatever mix or percentage that you want. You're going to get live, real user data on that 10%. That gives you a lot of great stuff, right? It could help you say, is it broken, and give you the ability to kind of roll things back, but it could also tell you, are people using this thing? Are they successful at using it, right? And getting that feedback quicker before you roll it out to all of your users.
Yeah.
Yeah. So really, I mean, yeah, testing in production, I think, is really huge, and especially, and I know we say this is an advanced thing, but especially if you have, let's say, a large, traditional or monolith type application, this is hard, right, to do, but it doesn't necessarily mean that you have to have all the other DevOps practices enabled in place to make this happen. And there's a ton of different ways that you can light this up. And we're going to show you, or Tiago's going to show you with Azure websites specifically and how to do this with our product. But you could use things like Azure Traffic Manager. You could use various solutions that split traffic up to, even if it's an internal thing, that helps only direct a certain chunk of the traffic.
Yeah.
You could have, let's say, for instance, one part of your service that dynamically detects that part and goes to a separate subset. You could have only certain users who enroll in beta, right, go to one thing. You could have feature flags to help light this up, right? You enable certain feature flags, and those feature flags help light up a subset of the traffic for your production users. Right? There's a lot of options and a lot of ways to cover this. We're going to just talk about one of them today, but I would encourage you, especially, no matter where you're at, and especially if you have really painful release processes, and when you go to production, to think about how, because this is probably a longer term thing, especially with a traditional or monolith app, how can we try to start thinking about this?
Yep.
What are things in the way we're coding now, or the service, or the other things we have, that we can start to try and implement this in our app? Yeah,
and especially if you're already confident with everything else, your production code is working fine. Now is start experimenting with how you could improve what's already in production, instead of always trying to chase up fixing bugs, fixing problems. Now you're going towards experimenting and improving your solution for your customers.
Yeah, and if you've got a large, let's say, change management, process of all these people have to sign off and buy in before the thing goes to production, that helps a lot, right? You say, well, let's push it out there. It's only 1% of people, or 5% of people, and we're going to be, it comes back to this is really great in conjunction with the roll back, roll forward kind of thing, because, you ideally, in conjunction with this, that helps, right? You can dial the traffic down to 0, and that becomes part of your roll back, roll forward plan, in this instance, to help minimize your risk and get you, have people start to be more comfortable with releasing features and code faster into production.
Yeah.
So let's keep on going here.
Here we go. Next one, user telemetry.
Yeah, user telemetry. This, there's the basic principle here is that within your code, and that lives in your app, you've got something that you're tracking that you care about, and that data then goes up to the telemetry service. And there's all kinds of products that do this. Ours, Microsoft's, is App Insights, and we're going to show you this a little bit later in the demo, but this is really important. This concept is really important because, there's one thing that we know, and if you watch the the DevOps Dimension Bing video we did that really comes through with experimentation, right? Is that even if you think you know what your users want and they tell you that's what they want, that may not be what they really want, right? Because if you measure what they're doing and are they successful or not, that's the data trumps all, right? And so user telemetry is really important for that fact because you're going to really know, are the users being successful at doing what you want them to accomplish? Are they even using it, right? Because the worst case is I think for the company and especially developers, you go off and code something away for 2 weeks or a month or who knows, even longer, and then turns out nobody's even using it. And on the flip side, right, I think it could be probably really rewarding for a developer to know that their stuff is really being used, right? So if you did do something successful, knowing that it was successful, kind of important, but yeah.
All right, and the last one, fault injection.
Fault injection. So this one is definitely an advanced one, and this is really where I would say you want to be more evolved, more advanced, because of what the nature of this one is.
Yeah.
Because what you're doing here is, the analogy that I like to give is this. Us ops people and most people in general are familiar with backups, right? People know about backups, and oh yeah, we have a very fault-tolerant, highly available backup solution. Okay, great, awesome. You got the highly available backup solution, no problem. Well, then the question that comes next sometimes is, well, when's the last time you tested it? and then the rubber really rubber meets the road, right? Because you could be doing backups for years, and if you never test it, then you may find that, well, your backups really don't work, and then everything you've been doing is a total waste. And I kind of think about this in the same way with fault injection, because let's say you have a highly redundant, fault-tolerant database system, right? Cluster or whatever, or front end. Maybe you've got a whole series of front end servers that have scale, and you're saying any one of those could go down anytime and it's no problem. Well, the kind of analogy to the backup thing of testing your backups, fault injection would be test your highly available infrastructure.
Yeah.
And that could be via manual means. If you want to start there, right, just power down half of the SQL server, right? Kill the instance, right? If you want to just go in there and do it. But if you get more advanced, you could have an automated process. I think a lot of people point to Netflix in this space and the Chaos Monkey and the Simian Army, where a lot of folks are, they have a suite of tools that inject failures for all kinds of things. And you don't, typically, right, that requires a lot of practice and guts, because likely you're going to have, practices in place to help recover from those kinds of failures. And you're going to have a plan, you're going to have a way to quickly push changes or updates to your infrastructure and or your builds or your codes to kind of back that up.
Yeah, make sure it's really resilient.
Yeah, you're gonna have a lot of preparation and probably a lot of other fundamental DevOps practices in place before you start powering down servers or killing them at random.
Or like Netflix, a whole region.
Yeah, just delete a whole data center and just see if you still live, right? Just unplug the cable, right? And see what happens, right? Okay.
All right, so we have one demo for you to show user telemetry and the test in production sample. So let's jump into that. So here we are back into our my Azure portal, where we have the Parts Unlimited solution deployed. And for the DevOps Funds the website, the main production website for our solution, you see that I have also a deployment slot called staging, which we've been using to deploy solutions. So what I set up when we looked at the release management part of the episode for release management, I set it up so that I deployed an update to the site that's in our staging slot, so this DevOps web staging, and one in production. So the production one, if I go into the code here, it has a discount of 20% on the page, and the staging one has 90%. And we want to pit the two of them together, sort of like I call it the Thunderdome test, to see which one of them will do better. And
The
then
Thunderdome,
The Thunderdome,
All
yes.
right. Yeah, bring on the dome.
Yeah.
Okay.
And we'll see which one does better. I suspect the 90% discount will win, but we'll have to see. And you leave out those two. You make sure that there's traffic. If anyone that's going to production, you randomly assign 50-50 who's going to get 90, who's going to see 20. And then over time, you'll see which one is doing better, and then you can keep that slot as the main slot. So the way to do that from here, if we have the at least one deployment slot, we can go into traffic routing and enable traffic routing so that for my staging slot, I'll give it 50%, and then it'll auto update the production slot to 50% as well. So once I save that, it's now whenever you browse to the production slot, it's actually going to route people between the two. So I had open here just to show you the production one, DevOps Fund Web, showing 20%, and now DevOps Fund Staging, it was showing, let me go to the first one here, it was showing 90%. And then in that case, what I've done as well from the application inside side of things, if I go here, I created a custom event from the trace that says, say for example here, the one I'm showing is, it's creating an event called carousel test, and the type is DO20. And when I pushed or committed all the way to production, the 20% one, it had carousel test DO20. So the way to check that is, I saved a couple of searches that you can go from search, one for DO20. I'll just expand the time range here to show us the last 48 hours. You can see that there were 5 people in production on the production slot that clicked on DO20. So that's 5 custom events. And if I go to DO90, you can see that there's been 9 of those clicks there as well.
So imagine that. People want a 90% discount over the 20%.
Yeah.
That's a shocker, huh?
So that gives us a very clear view that people definitely are liking the deal, the 90%, and then we can decide to go ahead and make that the production slot for a web app.
Yeah. So I think it's really important to call out here that, I mean, this starts to get into, the combination of user telemetry and testing production gets into kind of the concept of experimentation. And if you really want to get into that, it is a lot more complex. There's a lot of science behind experimentation. So you can get, depends on how specific you want to get here. I mean, and in this case, we're saying, 50-50 traffic, probably over some time, you start to get an idea of one versus the other. But there's a lot more to it if you really want to get deep into experimentation. For that, I'd recommend you check out the DevOps Dimension episode we did with Bing and some of the resources that we mentioned there on how if you really want to get into it, on how to drive an experiment, how to know who wins, and there's a lot of other things you want to think about here, but this at least gives you a flavor of how you can light this up fairly easily, and this is, I think, one of the big advantages of Azure Websites and our App Insights technology being used together, because you could get that up and running fairly quickly to get the foundation to run experiments. Yeah,
and if you implement your solution so that you can enable specific features for specific users, then as long as you have the telemetry to show you which users are clicking on the discount in this case, then you'll be able to tell which one is doing well or not.
Yeah, and you can, there's ways to export all the raw data as well, for instance, from App Insights. There's, you can plug that into Power BI. You can start to do a lot of different queries and advanced things on the data that you get here that is beyond the real scope of this module, but gives you the idea.
Cool.
Yeah.
All right, so that was it for that demo, just to give you a quick overview. And if we go back to our slides, we just have one last slide. This is the last episode of the series. I hope you enjoyed it. If you haven't watched all the other episodes, then do check them out. I've had a lot of fun with other people from Microsoft that helped me present. And as usual, check out DevOps Dimension. If the Bing episode that we mentioned today isn't out yet, it should be pretty soon. And at the end there, we have the hands-on labs for Parts Unlimited. There's a couple of labs there for App Insights and telemetry, so if you want to check that out, that's in there as well.
Yeah, so since we're on the last module, we'll go through all of the options there. The top one is going to give you kind of our home Microsoft landing page for DevOps. There's a lot of different things that we push in that space. The middle one that's there is the aka.ms/DevOps Learn. There are a number of courses that relate to DevOps from various topics, Azure Automation, there's things like PowerShell and a number of other technologies that relate in different ways to DevOps. And that's a good resource to check out.
That's an MVA?
Yeah, so that redirects to an MVA kind of course page. And then the second to last one, the DevOps Maturity Self-Assessment, that one's really good to get a kind of ballpark, I would say, of where your organization is at across a lot of the things that you should care about. We have this concept that we call 7 habits, and we give you a score on where your organization is at across those 7 habits, as well as some tips. And that, I would say, you should be able to complete in no more than about a half an hour, as long as you have the right people, answering that know the different aspects to answer that. But it also would give you, the ability, one kind of higher level foundation to assess where you're at and maybe give you some ideas where you might want to improve and tie those back to specific DevOps practices that we may have already covered here in this fundamental series.
Hopefully.
So, yeah, hopefully, yeah. Okay.
All right, so
Alrighty.
that's it for the series. Thanks, David, for joining me in this one, and hope you had fun as well. Thank you.